Така, виждате ли ме? Добре. Сега ще ме видите. Добре.
related technologies in our region and especially in EPAM. Probably you can share some interesting details related to this experience. I know that EPAM is one of the biggest learning partners also for Microsoft.
Yes, and I think Milan would like to share more information about that. But before, I also want to thank you for hosting the event. It's very important for Azure in Bulgaria. I know that Azure and Microsoft are very important to the partner for EPAM. So thank you once again. I'll start with saying
Just, Mikhail, can you hear us? Because I think Smilan...
I hear you much better. There is not so good sound from Smilan.
Smilan, I think you're muted. Can you check?
Can you hear me?
No, your headphones.
Yes. Is it better now?
Still cannot hear you.
I think it is better.
Can you mute yourself?
Yeah, sure. No. Sorry for the small technical issues here.
Not a problem.
Let me use your laptop.
Maybe I can stay near you and yeah.
Hello again. Is it better now or?
Yes, it is much better.
Okay, I will start with that EPAM has been working together with Microsoft on many different projects. When basically our partnership starts long before 2004, but 2004 marks our partnership with Microsoft for many different projects. Maybe you don't know, but EPAM is an engineering company with more than 37,000 employees, and actually 10,000 of them are focused on Microsoft technological stack, and actually 3,000 are with heavy Azure competency and skill set.
I know that
what we can
some partnership exactly around Azure competency with Microsoft for the region. Probably you know more details and can explain it.
Yes, actually we are client focused, and most of the solutions we prepare, they're targeting clients which usually have a quite strong background with working with Microsoft as a vendor. So it's natural that when we are trying to extend their platforms and automate their business, we have started looking into Azure and hybrid cloud. We have over 400 customers, enterprise customers, that have increased the amount in machine learning, big data, process automation, human-machine interaction, and Internet of Things. And actually, EPAM has made quite big steps, especially in the development in particular domains, like finance, healthcare, clinical trials. We actually won one of the Microsoft Awards for 2020 for income operational outcomes based on one of the solutions we provided for North America called Iceworm. The reason for this quite beneficial partnership is that EPAM has always strived to be ahead of the wave for different technologies and to move with the demand that comes from the business. And in the last 2 years, we have seen quite uptake into the demand for Azure solutions. Mostly this is based because the platform now gives almost the same functionalities as AWS and GCP. And the migration process for many companies has been more stable with less risk and less transactional costs. In order to meet this demand, EPAM has put forth upskilling and certification programs. Actually, one of the biggest programs for Microsoft, because we are heavily supported by Microsoft, is the upskilling program in 2020, targeting Central and Eastern Europe, where over 2,000 people from 16 offices get education and certification in Azure.
Yeah, this looks impressive, really. And I will invite now also Radoslav Stankov to our discussion, which is related to different clouds. It is something which is probably interesting. You already mentioned something about Azure and AWS. I will try to explain that this is not competition. This is just something which is good to be discussed, because people usually consider which cloud to use, what is the current state of different platforms. So Radu will join me here in the discussion. And I think that you know him. Here is the camera, so where is the camera? Camera is over there. Yeah.
Hey guys, how's it going?
So this is something like discussion where I would like to have some kind of consideration. Where are different clouds in the context of current state and demand from the business? We already started with some things about Azure. Probably I will just add few additional notes and will ask you to support me. In general, Microsoft Azure is probably the fastly growing cloud, which is close to AWS. We will discuss about different numbers. Azure has already more than 60 regions, and exactly Microsoft is pushing in several specific directions. One direction is hybrid cloud. In hybrid cloud, Microsoft is going much more like part of his business strategy. So you can consider that more and more solutions around hybrid clouds are targeted from Azure. Also, there are several different sub-areas where Azure is growing pretty fast. One is IoT. For IoT, there could be also interesting comparison with AWS, but yes, this part is also pretty fast growing. In the context of machine learning and artificial intelligence, Microsoft is targeting mostly automated and semi-automated machine learning, because different vendors are going in different directions. For example, Google is going in deep details about specific custom algorithms, but Microsoft is targeting mostly common cases which you can meet in the context of artificial intelligence, and exactly in this area they are trying to offer us much more features. So probably we can continue with Google Cloud. I think that Sam, you have a good experience with Google Cloud.
Well, not really. I mean, Google, not professionally, if I can be clear. So, in fact, I was kind of wondering whether we should, but I need to make a premise. I'm totally biased for Azure and AWS, at least, because due to not having a lot of production experience in Google Cloud. So I did some pet projects, if you want. But I cannot say very good things. In fact, for me personally, Google Cloud has been the only instance where I had resource issues. So it just once it happened that I had some storage created on Google Cloud in use for a couple of months, and then all of a sudden I couldn't anymore use that storage. It wouldn't mount in the VM. And this has been actually the only cloud provider to break as much and not having the issue fixed. So yeah, I don't have too much experience with it. But since that happened, I haven't been considering it when choosing a cloud platform. You know, once you have a bad experience with something, you try to avoid it. And I guess this is what I'm doing right now. Of course, it could be me. So it might be that I don't have enough knowledge and don't know the platform too much, too well. But that happens. So yeah. Looking much more optimistic on the AWS and Azure side. I'm sure that Google Cloud is very strong on machine learning. You know that they have originally developed the Kubernetes platform to adopt it in there. So it definitely has advantages. What I'm seeing is that it's currently being preferred for Java developers, Java backend developers. It seems to be the go-to platform. But yeah, what do you think? Am I totally missing the point here, or am I kind of getting the right division in terms of development stacks?
Yes, probably rather more.
Yeah, I haven't had much production experience, almost any, with the Google platform. One area which is very used in the Google Cloud is their Firebase offering, actually, because it's targeted to basically developers and people who don't want to own their own backend. Like the idea there is I know a lot of people, and I actually worked. That's my only experience with Google Cloud was exactly Firebase, and it's like they're basically their hat for, okay, you need to build a mobile application. This is basically what you need for the backend. You don't need to put any backend infrastructure. If you need any backend infrastructure, you use their like Lambda functionality. And I think Google, on that sense, is the other area where a lot of people use Google Cloud just for Firebase.
Yeah, really, Firebase is one of the features where Google has interesting experience. From the IoT side, I can say that they have not so mature framework like AWS and Azure. And also on the level of platform as a service, I think that they have not so many components like Azure. But from another hand, Google is very optimized for some specific tasks, like when you have some kind of processing, image processing, when you need on the relative low cost compute. For video industry, for example, Google is quite good.
Yeah, I don't have much. Like another Google API, which is very useful, is their image API, which they're pushing. Like I have used both that and the AWS one, and for the most cases, they give you the same results. But Google is a lot more faster. It's a bit more expensive, in my opinion, but it's a lot better for a lot of like edge cases, like finding buildings, famous people, logos, or a lot of that. So their machine learning, again, is Google's. But that's another area where I have experience with basically using their service of that, which part of the cloud offering.
That's correct. And probably we can switch to AWS also. I know that all of you have experience. This is an event on Microsoft Azure, so we do not have comparison in the context of competition. We are just discussing in which platform you feel yourself more comfortable in specific business domains, for example.
Like, to be honest, I haven't used Azure in production at all. I only have used AWS, and it's more a lot of like the enemy you know, a kind of situation. And like, again, AWS have been so long, you actually know all the bugs and know how to handle those. And again, they're like have, I think, everything under the sun. Another area where, because we discussed Firebase, is one area which AWS is pushing very hard for the last 2 years, and it's something called AppSync. I don't know if you are guys familiar with AppSync. As the AWS platform thing, I think it's a very interesting approach to connecting all their services, and the way they're actually combining like all the small pieces in their own infrastructure around that. I don't know if Azure has something.
Can you explain some more details about it?
AppSync? Yeah, so AppSync is very similar to, like, it's basically targeting the same group of people who are targeted around Firebase, but it's mostly based on like a GraphQL API in the background, and it is used to basically connect, it's basically a front end for applications to an AWS group of services. Like, for example, what they provide is they actually say, okay, AppSync is this layer of APIs where you can access different areas from AWS, which are targeted specific for applications. And on top of that, again, they provide a lot of like code samples, like code generation, like you want a login. Okay, you use AWS Cognito, but it all passes through AppSync, instead of like the Google where they offer like, okay, you have just Firebase and everything goes through it. With Amazon, you just pick and choose. They also have, again, switchable backends. Like by default, I think they're like with DynamoDB. And again, you can just define whatever you want in the visual editor. You can use Lambda functions. But with Amazon, this is just like a front end for your team to work with a bigger group of AWS services without you actually writing much code. And they, again, handle all the authentication and permissions and so on.
Yeah, understand. Azure offers for mobile devices, mobile services, which works in a similar way in general. But I got the idea which you offer, and it is something which is also trying more and more features on the backend to be offered like a backend as a service.
Yeah, exactly. Like, for example, you want your login, like you have an all-out service, you just say, okay, this and you don't need to handle all those cases.
Yes, and probably also Smilen can share some experience. I know that he works on projects with both Azure and AWS.
Actually, not exactly. My clients mostly are enterprise clients in financial sector and airline backend services. And historically, they have been existing and operating from the 70s and 80s, which means that you can imagine that .NET and Microsoft-related technical stack is the most used technology for their legacy systems. So on a few occasions in the last 4 years, we needed to estimate should we continue extending business functions in the cloud through AWS, GCP, and Azure. And GCP was left out because of the risk and limited functionality and support. And for AWS and Azure, interesting value proposition, because usually when a customer comes asking for migration or migration to cloud, especially in those sectors, security and availability are the most important key functions. And security not only from the perspective of the system itself, but the ability for the client to support and maintain the system in the future. And before AWS was quite more established. The demand for people skilled in AWS is quite high, but there are many experienced professionals that can be hired, while for the Azure, this was not the case. Also, the migration from on-site or on-premise data center was very difficult, and usually will take a lot of time because of built-in faults in the system, which created this illusion of risk and security. Because many companies are not worried that cloud is a public place, but mostly when this migration happens, their own skill set will not be enough to handle the migration. And back in 2017 and 18, Microsoft was not giving compelling advice for companies to migrate, at least not on a reasonable cost. But in the last 2 years, what we observed is a quite interesting offering in the hybrid architecture. So many companies are coming back because the support for some of the main servers, like Windows Server 2008, which is quite used in financial companies, is going to end soon. And the people usually need to choose. Either they need to migrate or basically upsell their Microsoft account. And in the last year, Microsoft proposed quite a good cost savings as long as you're ready to migrate using their internal migration data tools.
Yes, that's correct.
So the value proposition.
Yeah, and I can totally relate to that. So the current system I'm working on was built on AWS just because it was the first cloud vendor. So essentially, AWS made an easy win there. It was an easy decision because there was not much competition. Not sure what year it was built, but probably before 2017. But now, as Azure is being more and more mature and also expanding its users and company base, we are actually evaluating switching to Azure. So we are estimating how much it would take to convert all the resources into the Azure cloud, which I'm really happy about and looking towards to. For me, there is nothing that beats Azure Active Directory. I don't think there is a competitive solution out there. And it's, AD has been historically deployed within many organizations. So it is currently being used by our client. Moving to Azure would facilitate many of the integrations. And we're actually also using Azure DevOps right now. So, it becomes a single integrated stack for us.
But other clouds also provides identity management services. Just the compatibility is the case, as you explained.
Right. I think there is no single software that is not compatible with Active Directory, or at least supports a subset of the functionalities of directory services.
Absolutely. And because we started this about the price, it is interesting probably to discuss about the pricing models, because different clouds have cloud providers have a little bit different pricing models. For example, in Azure, we have different options. You can have pay-as-you-go if you are a small company or just independent customer. You can pay for Azure via cloud solution partner, or you can have enterprise agreement. And if you have enterprise agreement, for example, you will have specific service, you will have probably more options, but you need to be a little bit more bigger like consumer of Azure resources. If you have good numbers like Azure resources which you are used, you are able to have also pretty good discount. It is a little bit like in automotive. In Google, it is quite different. Everything is with strict pricing model, which is public. But interesting about AWS. Can you share some additional insights? How is the pricing model in AWS?
I mean, it supports basically the things you mentioned. I mean, they call them with different names, where you can get usually what they call them like short-term and long-term. Like, for example, you can buy for like 2 years ahead. Like numbers, like let's say I want 20 EC2 instances, want to prepay them. You can also have like they call it more like enterprise support and business support, where you have, okay, if I have a ticket, return me in an hour, in a day, or if you don't pay me, I don't know when, type of situation. Basically, they support a lot of those options. Also, for them, again, it's a lot of companies pay by the go, but you can also, again, schedule, okay, this is my baseline and I pay a bit more upfront, but it's cheaper over the time because I committed for the next 1 year to 2 years and so on. Also, they have, I can imagine in Asia, you also have those, in Amazon, they call them spot instances for EC2, where you can actually rent somebody else's machines which are unused. Like, for example, if if Mishu paid for 2 years of AWS for a single server and he doesn't use it, I can actually pay a lot cheaper to use the server, but the moment Mishu wants the server, I'm kicked out. Of course, there's like, again, processes around that, and a lot of people actually use a lot of like spot instances. Like, for example, we use a lot of spot instances for our Kubernetes cluster, where we prepaid for like a year for a couple of the base machines, and for the old auto-scaling, it's just spot instances. And this kind of work.
Yes, it is the same in Azure with reserved instances. In GCP, we have also similar options. But what you think about so named, I'm not sure about AWS, but in Azure we name it burstable instances.
Burstable, what does it? I don't know.
This is when you have actually not guarantee about availability. When you have actually some computing which is available for some time, but after that it could be used from other customers.
Yeah, that's the spot instances basically. That's what spot instance is. Somebody else can. It's not you pay for this machine, but somebody else can just kick you off because they paid for that particular machine. And yeah, I used a lot of those. They're quite good for with auto scaling, especially like, again, for Kubernetes clusters where you don't care, you just scale and unscale, and it works quite well in those cases where you don't care about the computing power.
And do you have any insights about connectivity? Because connectivity is also one of the features which are very important for modern cloud providers.
So
In terms of, do you mean like in terms of bandwidth or network quality, or more like flexibility of the network?
Exactly.
Right. Well, so we've never had to measure performance of the network backbone, but we had we had to come out with a very complex network topology in our current setup, and that was possible on AWS using Transit Gateway and different VPN providers. At least for the managed part of the network, I've never heard about complaints. So it always performed up to spec. Now there's some discussion around the availability of the different cloud providers. They have different definitions for regions and availability zones, so it's not fair to compare them one-to-one. Because obviously availability zones in Azure are, as far as I understand, they are connected. We can think of it as being in the same physical location, the same fence. Obviously, they have isolated power supplies and hardware equipment, redundant equipment, but the data link would be very, very fast between availability zones. I hear the same feedback about availability to availability zone network performance in AWS. So from my point of view, they are all up to spec. Again, no experience with Google Cloud, so it's difficult for me to speak about that.
Actually, now availability zones in Azure are quite similar to availability zones in AWS, but in Azure we have two different things about availability. We can have availability groups which are related to the local data center, and availability zones are already availability groups which are related to different data centers but in the same region. So we have these two things in Azure, but zones currently in Azure are quite similar to what we say like zones also in AWS and in GCP.
Yeah, that's good to hear. I haven't kept very up to date on that subject for the last year, so it's good to hear that they're converging to the same definition now.
Yes, the features are very similar. Sorry, yeah, please go ahead.
Yes, I was going to say that this was an issue we had 2 years ago as well. Because when you're preparing a proposition to a client, you need to be very exact. And although the naming convention is similar, it's not the same.
Yeah,
it's very difficult to actually. At the time, it was very difficult to compare.
But
nowadays,
it's totally understandable. Like we had a talk at JS Talks where I explained how I built my own cloud infrastructure. That one was very interesting and a stupid idea, so don't do it. But that's the final conclusion from that talk. Never try to build your own cloud infrastructure. It was a very stupid and costly idea. But essentially, when you try to build a cloud from scratch, you need to make a decision about what availability zone means to you and what is a region to you. So there is no single one definition. But it's good to hear that different providers are adopting the same definition so that we can avoid some of the confusion, right?
Yes, exactly. And what you can say as conclusions of this discussion?
I can start maybe.
Yeah.
What I see, it's a quite positive trend for Azure in the next 3 years. Mostly because after COVID-19, the digital transformation for all the industries like financial industry and airlines has started moving forward with migration processes that have been basically left for the future. So basically future is now. And even for companies that already have established cloud on AWS, when they try to basically segregate the risk, they will look into Azure. And mostly because they already have vendor expertise, account management on the side of Azure and Microsoft. Because if you look into pricing on a very holistic, generic way, they look the same. But on enterprise level, the calculations are a little bit different. And there, Azure makes quite strong step ahead with the licensing. So I would expect that Azure will continue growing their market share, especially when we are going for multi-cloud solutions.
Yeah, this is where I can probably take off of. So this is exactly what I wanted to say. We didn't discuss data lake, which is becoming more and more of adopted in organizations. So I think Azure and Azure Data Factory and Data Lake are very advanced. They are integrated with the entire productivity stack offered by Microsoft. You know, we integrated with BI and Office 365 tools. So data lake, I think, is something important to consider as well. But as Milan said, I think the right approach is multi-cloud, and just want to make sure not cloud agnostic. So it's not necessary to build your software in a cloud agnostic way. Rather, maybe take different cloud providers for the best thing they do. So Google Cloud, when it comes down to machine learning, Azure for the entire productivity offering, and probably AWS has some very strong competitive points, which are not straightforward to me at this point. I know they they probably provide also interesting pricing solutions, but in my experience, AWS has always costed more than the offering at Azure. So I've always went with Azure when it came down to cost. But yeah, I think multi-cloud is probably the best approach. So cherry pick the strong parts of different providers and try to deploy them within your organization. I'm also interested to know Radi's opinion on this.
Yeah, I mean, one of the things I'm thinking that AWS is actually going to adjust some of their pricing at some point if Azure starts to catching up a bit more in those regards. And apart from that, I really like the trend of like kind of standardizing on a couple of things which are basically the same between clouds. The way I see it is a bit more like having something like, let's say, SQL was for the different databases. Like you can write Postgres, you can be in MS SQL, you can be in Azure SQL or whatever. And I can see a lot of the things around the clouds for the backbones be that, and the clouds try to differentiate on the services, like for example Google with the machine learning, AWS with like cloud sync, or with some of their other custom solutions around like the crypto stuff where they're trying right now. Microsoft with more the productivity Active Directory, and for the rest, which is for I think a big chunk of the apps, like the computing powered storage and the database can just be the same.
So thank you very much to join this discussion, and hope that you will continue to enjoy the conference. Thanks, and
thank you.
Thank you very much, Mikhail and Radi. Bye-bye.
Няма проблем. Ти имаш истински Teams отворен тук или нямаш?
Имам само твоя, видео нямам какво.
Какво имаш преди, имаш само моя?
В твоя акаунт съм влезнал.
Да, чудесно. Можем ли да си джойнем на следващия митинг? Защото аз трябва влезна В един идиотски митинг ни разкидлнаха от Луксотика преди 2 часа и просто да го пуснем Димо от тук. Потегляш ли?
Да, ще трябва да кажа, че...
Разбрахте, мерси много. Къде ти е той? Така, да го клоузнем.
Как?
Не, така. Той. Така. И сега отиваме в това е брейк.
Дизайн.
И после ще GDPR. За брейка може би всъщност чакай, защо толкова много снимаме пуснати.
Няма, само това.
Така. Тук в един момент това нещо като се join един, аз мога и да му кажа сега, нали може просто да го стримнем него,
Добре.
защото Пешо Лалов не знам дали ще се включите май всички се отидоха по някакви задачки. Сори, че така стрес, нали, малко имахме, но мисля, че нещата се завъртяха. Дидо, ти искаш ли да го питаш Димо, като си join някакви неща или няма да ти е комфортно?
Не мога. Въпросът е да пиша
Я покажи какво се вижда от
на
телефона.
глас.
На глас по-скоро. Аз трябва да влезна в митинг, защото това е колко. Иначе, къде ти е на тебе Teams, да?
Няма да тръгна обаче.
Ето той
Не мога да го плейна.
Не
мога да го плейна.
Трябва да влезна в шибания митинг.
Да, бе,
Значи,
Hello everyone, welcome to this edition of Azure Bootcamp. My name is Ivo and I'm part of Bolshayo. We're happy to host this edition of the event at our office since Azure is one of our core technologies that we work with. So enjoy the event and let us tell you about ourselves a bit. For us, it all started back in 1998 with the foundation of Processed. Since then, we've been gaining knowledge into the domain that's today known as IoT, and Azure is a big part of this.
We've been pioneering the connection and management of devices since 1998. Back then, our solutions were deployed on-premise, and nowadays they're offered as software as a service on infrastructure such as Microsoft Azure. By 2015, we already had over 6 million connected devices. At the same time, with the acquisition by Bosch, we realized we needed a new office setup.
Hello from my side, my name is Peter Lalov and I'm department manager at Bosch.io. I'm going to show you how we've turned our colleagues' needs from work environment into reality. Once Bosch.io decided to move to a new office, we've asked our colleagues for support. Our colleagues create work groups like layout and furniture and delivered their needs, which were transferred to the architects. The end result of our effort is a place that we feel comfortable, we have boost of our efficiency, and we have a lot of cooperation. Thank you and enjoy the event.
We've been gaining knowledge into the domain that's today known as IoT, and Azure is a big part of this.
We've been pioneering the connection and management of devices since 1998. Back then, our solutions were deployed on-premise, and nowadays they're offered as software as a service on infrastructure such as Microsoft Azure. By 2015, we already had over 6 million connected devices. At the same time, with the acquisition by Bosch, we realized we needed a new office setup.
Hello from my side, my name is Peter Lalov and I'm department manager at Bosch.io. I'm gonna show you how we've turned our colleagues' needs from work environment into reality. Once Bosch.io decided to move to a new office, we've asked our colleagues for support. Our colleagues create work groups like layout and furniture and delivered their needs, which were transferred to the architects. The end result of our effort is a place that we feel comfortable, we have boost of our efficiency, and we have a lot of cooperation. Thank you and enjoy the event.
Hello, everyone.
Hi, everyone.
So today we have a talk with Timo Rusinov. The topic is designing GDPR compliant identity management. Before jumping into the deep details, Timo, could you share some thoughts about you?
Well, I'm in the IT field for 15 or more years, and currently I'm a manager of a quality engineering team. I was architect of several Azure and on-premises solutions during the past years. And the last project that I was architect and leading architect was a global marketplace ecosystem with one central solution and multiple others.
Being an Azure topic, what do you like most in Azure?
Actually, I have worked a lot in multi-tenancy and identity architecture. So the things that I like in Azure are mostly connected with Azure AD. However, my favorite Azure technology is Azure Front Door because it actually enables you to have less deployments of your system and be accessible in a fast manner from the globe.
Mm-hmm. Great. Okay, and being closer to the main topic, what was the most complex solution, complex architecture that you have done?
Actually, this global marketplace solution for the current company that I work for, and it enables the company to sell digital digital assets. Let's say smaller applications to their clients worldwide. It was designed for 6 Azure locations, 6 regions, and all of the instances there are active all the time. So it was a pretty complex thing with custom identity solution, with let's say 14 web apps currently in it, and yeah, that's it.
Let's dive into your presentation. I think you started multiple regions,
yeah,
identity management, and of course GDPR use case and identity management.
actually, the thing that was most complex about this solution was because it's on multiple continents in multiple countries. That means multiple legislations. And having multiple legislations means GDPR, the laws in China for privacy, and so on. Sorry, I don't hear anything.
I've lost you. Not sure how was for the others.
Something happened with my internet, maybe. So, yeah.
It starts to share the challenges, multiple continents, etc.
Yeah, multiple continents means multiple countries, multiple legislations. So you don't only follow GDPR, you follow the laws in US, you follow the laws in China, for example, and this means different privacy laws in different locations. For the identity solution, that means complexity.
Mm-hmm. And here the challenges were in those legislations or technology?
Both. Because legislations means business requirements, and you need to implement the business requirements through technology so that they comply.
Cool. Can you there then deep dive into your presentation?
Yeah.
There are more challenges and use cases that you just started to share.
Yep. This is some about me information and my previous competences and so on. But let's dive into GDPR. So these are the 7 key principles of GDPR. And lawfulness, fairness, and transparency. This means that you need to always follow the legislation that you're in. You need to use the personal information in a way that is fair to the person that is owner of it. And transparency means that he knows what you're using the information for. You need to use the least information possible for least purposes possible, and you need to store it for, let's say, limited time, the time that you need to use this information. You need to ensure that the integrity and confidentiality is followed, so no one can change this information, excluding the owner of the information, of course, and you need to make sure that you don't share this information unlawfully outside your company. Accountability means that you're accountable for any breaches and everything that happens to this personal information during the time that you process it. So, what is personal data? Actually, we used a GDPR consultant, a lawyer that defined for us the limits of the personal data that is stored on our site. And by definition, personal data is any information that can identify a natural person. So that means that this is not only name or personal ID numbers or something like that. It means that this might be a combination of attributes that we have in this identity. It can be, for example, the position of this person, his field of operation and city. And if you have, for example, CEO of automotive company living in, let's say, Munich, you can identify to 2 or 3 people, which also is considered personal data under GDPR. You need to anonymize and pseudonymize information, but pseudonymized information can also fall within the scope of GDPR if it is not so difficult to get to the real data after that. So let's have some more information. On the other hand, we saw what the companies have right to do. Let's see what people have right to do. They have the right to access their information at any time. They have the right to be informed what is and how their information is processed, and they have the right to be forgotten. So at any time, if I stop using some service, I have the right to say, okay, forget me. And the data operator, we'll see on the next slide how this is managed in some special cases, but in most of the time, the data operator needs to delete all the personal data that is connected with this person. The fines that are applied are really severe. Currently, the severe violations goes up to 20 million euro or 4% of the turnover of the company, whatever is higher, and less severe violations can sum up to 10 million. On the other hand, what is consent? The person that is giving willingly his personal data should be aware what exactly is he agreeing to, for what time limit, and if he doesn't agree, that means that his personal data cannot be processed. This is privacy by default. However, there are special cases. And the special cases are analytics. When we have marketing analytics, and marketing analytics does not work well with the right to be forgotten. Because if I have visited pages, got some products and so on, after my data is deleted, that is actually modifying the statistics, and the analysis is not already adequate to what happened. And on the other hand, we have security logging and some cases, for example, with banking, payments, and etc. You need to keep security and audit logs for payments and who accessed accounts and so on for 10 plus years. Here, the right to be forgotten does not work. There are some national security laws, like the Patriot Act, that is also acting here in the US. And it's very interesting what is happening in when we are outside national borders and outside EU borders. There are countries that have restrictions to store personal data outside national borders. Such countries are China and Russia. And you actually don't have the right to store them in another data center somewhere. On the GDPR, in this case, there is a EU, US, and Swiss US privacy shield framework. And these are designed by the US Department of Commerce and the European Commission and Swiss administration in order to provide the same level of privacy for the European and Swiss citizens in the US. And for example, Microsoft and Azure in particular are part of this privacy shield. So we needed to design a marketplace, and we had a marketplace designed, multi-tenant, multi-country, and we needed to figure out how to do a globally distributed IDM. We had some options. The first option was Azure AD with Azure AD B2B and Azure AD B2C. Our requirements were to have both federated users, internal users by the company, and we needed to have self-registered users, and also we needed to have users with social identity able to log into the platform. So this was fulfilled by Azure AD with B2B and B2C, but because of security restrictions on our side, Azure B2C and Azure B2B were not available at that time for usage. So this was dropped as an option. We have examined some third party, for example, Auth0, Okta, Optimal IDM. Most of them fulfilled our requirements, but we needed some, let's say, additional automation and additional development so that these products can be adjusted to our needs. And the third option that I am presenting actually is based on ADDS, ADFS, certificate services with a custom database and so on. Let's see. This is how Azure AD with Azure AD B2B and Azure B2C would work with our software as a service components, our web apps, and servers. So the users from, let me just go to this screen. The users from the company are going through ADFS and accessing our environment. The federated users from or self-registered users are going here to Azure AD and Azure AD B2B to our services, and the social accounts are going to through B2C. So our next option, the third-party IDM, you have a black box here, which authenticates all types of users, excluding the corporate ones that are passing through Azure, through on-premises AD and ADFS. And yeah, in this black box, all the users are registered, but actually the control over the code is by a third party. What were the challenges? We needed to design a globally distributed identity as a service. So we had some difficulties with Azure AD and also with other solutions, third-party solutions, that the personal data cannot be segregated in a particular data center or region. This means that our regional legislation is really hard to follow. So if, for example, Germany wants German data only in Germany, you cannot do that. And actually, the GDPR compliance is mostly in the hands of the provider. And having in mind that we are designing a global marketplace with identity solution within it, this was not a good idea because actually we are providing to applications identity as a service and consuming identity as a service from a third party, no matter Microsoft or someone else. This was really not the thing that we wanted. And security logs are part of the provider's offering. So someone else is storing your security logs. The hard to implement additional requirements if needed is, let's say, we are submitting some requests, and no matter if Microsoft or Optima or whoever puts them in their backlog, and they happen according to their prioritization, not ours. So what we decided to do? We decided to do a custom solution. And you can see it's pretty similar to the third-party solution that we have. But now the custom solution is under our control, and it is not a black box anymore. What have we done? So at that point of time, Azure Front Door was not an option for us. So we needed to deploy in 6 regions. In this case, here we have presented only 4. On 3 continents, 6 regions. The first main issue was how to direct the people to the closest location. We have tried to implement front door there so that we can deploy, for example, only in Europe and address from all other countries. But as I said, because of internal reasons, this was not an option. So we are having a traffic manager. And the traffic manager is redirecting the customer to Asia Pacific or to EMA or to North America. What do we have as a second main issue was what kind of storage can we choose in order to be globally distributed. We have evaluated SQL as a service. We have evaluated SQL on virtual machines. We have also evaluated Oracle and Oracle RAC. But actually, because of limitations on all the database providers that I've mentioned, we have chosen geo-distributed Cosmos DB. This was chosen because of the synchronous replication and the ability to deploy it worldwide with replicas that are close to real-time synchronized. Now, as you remember, I have mentioned that there is a use case for storing data only in a certain region or certain data center. For this, we can have multiple local identity storages in the desired regions. Actually, this solution has several, the identity service consists of several web applications and several components. And one of them is the front-facing pages and profile editing capabilities and so on. We have Identity Server 4 with custom extension components. And here, it's not written, but we have a data virtualization service, which enables the identity service, which is deployed in multiple regions, to access both the geo-distributed identity store and local identity stores. Why do we need the local identity stores, and what will happen in case, for example, one country decides to close their contract with this marketplace? They only cut this connection to us, and we don't have the accounts anymore. On the other hand, we have in this identity service, we support self-registered users, and also we support users from social networks. In order to have the corporate users, we have deployed an ADFS farm, and we have designed it with proxies and ADFS servers. Here we had, again, some limitations, because if we're using one farm and we're using SQL, we lose the synchronous replication, so we're using Windows internal database and ADFS capabilities of synchronization. Any questions?
From my side, how do you solve it for Russia and China? Can you?
Russia and China are not clients of this platform until now. However, this can be solved with this local identity storage in a Russian or Chinese data center, and the data virtualization is going to be able to fetch data from there, but we're not storing it anywhere, either in Asia or EMA or whatever. We're just processing the data, processing the logon request, and we're storing the data only in memory.
Mm-hmm.
We're doing the same here with the geo-distributed identity. However, actually, it is stored in multiple data centers, so it doesn't matter.
Okay.
But these local identity storages here, just a second, here, these are designed specifically for this kind of use cases. Also, our security logging, let's talk about a little bit about that. We have security logging that keeps information, but only on pages that are ordering and payment, which is outside the IDM. And we're actually providing our applications with a fake ID. All these identities. Here is the personal data. However, the applications that are integrated with our identity service are receiving generated by us ID, and the only connection between this generated ID and the real identity that is stored here is within our identity service. For example, as I have a Dimo Rusinov account at something.com, and my account on the other end with the applications is something different, something custom generated. It's partial GUID in our case. So, what are the challenges with the custom solution? You need custom development, of course, and you need to design the data segregation, which we already talked about. You have high operational and hosting cost because you're only hosting this for yourself, which is not the case with Azure AD or with Optimal Cloud. But you have a flexible solution. You can extend it however you need, depending on the applications that are going to be integrated. And you have your security logs under control, under only your control. So this is the solution that we chose. It's running for, let's say, 9 months already. And I think the client is happy and we're happy with it.
Do you plan to create a product, sell it to their clients?
No. Actually, the idea of this marketplace is for the company that I work for to sell to their clients, for example, tax audit applications and so on. And their identity solution is for themselves. It's custom for, it's strange because it's not one company. It's a network of member firms, and there are 150, close to 150 companies in the world that are part of this network. So yeah, it is a product, but it's mostly internal product.
Okay. Trying to see. And I have the usual question: what was the biggest challenge in this product during the development, considering its complexity? Can you share?
Okay, the first thing that was a real case was this with the database, and we had several issues there. And one of them was that the backup and restore of Cosmos DB is not under your control. But we managed to have several sessions with the Microsoft product group for Cosmos, and they were really helpful. And we had our backups set up in the way that we have designed, and the RTOs and RPOs that we needed, and we had as requirement.
Sorry that I'm interrupting. Does this mean that Microsoft aligned with your expectations, or they give a solution that was built in into Azure?
The company that I work for has a strategic alliance with Microsoft. So we got a custom solution for our Cosmos databases.
Okay, so if next question,
I'm not sure that this is implemented and has general availability, but it is implemented for our containers.
So if I'm a company that struggles and have similar issues, how do you, and we do not have such contract with Azure, with Microsoft, what would you suggest?
Actually, we didn't use it in the beginning. Actually, we dropped an email to the mail of the product group, and they were really happy to help us. They're really responsive, so I'm not sure that this is because of the contract. I think that the implementation was partly because of that. But otherwise, they're really responsive, and you get a solution that will work out.
So you're encouraging us, if you have similar struggles, issues, immediately to contact the product group and not start.
No, not immediately. Yeah. Okay,
wasting our time finding workarounds.
Yeah, but we have tried to find a lot of workarounds, and we had a lot of thought about that, because actually the team that worked on the whole marketplace with the identity solution was 35 people. 6 of them were architects, and we had PMs and developers and so on. But actually, one of the architects was working on the design of the Cosmos DB, let's say, several months. So yeah, and he was working also with the product group. Actually, she was working with the product group.
So work with a great team. Congratulations. It's great opportunity.
Thank you.
Okay, from my side,
Yeah.
maybe other questions I don't have.
Thanks a lot.
Thank you for your sharing, and looking for your talks with you.
Thanks. Have a great day. Bye.
Thanks. Bye-bye.
So, welcome again. We are now with Kalin Dimchev, who is General Manager of Microsoft for Bulgaria and multi-country CE region. And I'm very glad that Kalin accepted our invitation. So, welcome, Kalin. And it will be great if you can share some thoughts about Microsoft and Azure strategy for the region. What is the most important, how you see Azure in Microsoft plans for the region?
Hello, Michael. Hello, everybody. As Michael mentioned, my name is Kalin Dimchev. I'm the country manager for Microsoft Bulgaria. And indeed, it's a very good question on what we in Microsoft see in the region Central Eastern Europe in terms of cloud development and our presence. Because with the current times in the past 8 months, there were so many changes in the way businesses work, in the way different industries are challenged and prioritizing their infrastructure and technology usage. And fortunately, our region is as much dynamic as every other developed region. And in April, I believe, Microsoft announced its plans for one of the biggest CE countries, Poland, to invest long-term into developing a data center with certain partnerships that will focus on all clouds that we cover, meaning Azure infrastructure, Office 365, our collaboration cloud, and also our business management software, which is Dynamics 365. So basically, we do see potential, and we see our expansion in the region as key for development of the business, development of the government technology impact, and also of our presence in the countries of this region.
Do you think that this new approach of work actually helps to develop these new technologies, cloud computing, and especially Azure?
Well, we have multiple entry approach of how we see the development of technology. It's not only about the platform and the availability, because even now it's available for the many data centers we have across the world. It's more about the local skilling and collaboration on the markets, meaning skilling how many people we have technically enabled and with the up-to-date hot topics for enablement, how this is done in scale, and also how this links to the customer and the companies that do development into certain areas, because we see that the market is so dynamic that unless we are able almost real time to match supply and demand in skilling in the hot topics, something which is 6 or 12 months old, it's already not very appealing to the potential users. That's why we see this ecosystem of skilling, of customer specific development requirements, and the companies that provide and work with this development very crucial for the success of the cloud platform of Azure. And exactly these are our priorities in now and in the future. How we better understand the local requirements, how we better work with the businesses and the companies that do development, and then how we quickly respond to those requirements to skill and certify people.
We know that more and more people in our region from the community stay familiar with Azure and did certification, started to work. Do you think that this knowledge from the community members actually will help Azure to stay more popular also for the business?
Absolutely, this is actually key to the business when one platform is more recognized, when there are more people knowing and working with the platform, and most of the time the business does its choices based on the skilled people on the market. So what we also see, a lot of the businesses, they do start to run their own certification programs, meaning that they would like to keep up the skills of their people, their teams up to the required level. And this also creates opportunities for them, meaning that new customers can go to them and be sure that they have the required skills. They can propose options and risk management to their clients depending on the preferences and the platforms they use. And actually a lot of the digitally advanced, digitally mature customers, they're multi-platform because for many reasons this is something that they consider, and they want to know the different platforms and the most advanced platforms on the market. So all this together, I think helps us, and not only us, helps the businesses be more deep into Azure, and also follow up on the advanced services, because as you know, the services that we have, they constantly improve, and we constantly add new ones into our portfolio.
Great. And what you want to wish to attendees of our event?
I first thanks to all for attending. I think that's everything in the schedule is very appealing to everybody who is familiar with our platform and who wants to be on top with new developments and new topics. So I just want to wish you luck and success into our constantly changing environments. And as you have seen from the Azure growth usage, which just recently announced our annual result, there are so many great opportunities with any industry, any business site, any business problem that we can link to different solutions in Azure. So I'm sure you have a lot of fun and a lot of interesting projects to do with our platform.
Thank you very much, and thank you for joining our event.
Thank you. Thanks all.
Have a nice day. Bye.
Have a great day. Bye-bye.
So, welcome back. We're again here with Radoslav Gatev, and we will talk about distributed applications runtime. So, welcome, Rado. Thank you for coming. And I would like in advance to ask you several things.
Thanks for having me.
Probably the most important is to share some thoughts about you, how you start with Azure, and which Azure technology is your favorite one.
Okay. So I'm a Microsoft Azure MVP, and I've been working as an independent consultant for the last 4 years. And I've been helping clients to adopt the cloud. And they vary from small startups to big enterprises having a different variety of problems. And I've been taking on mostly architectural roles like solution architect or software architect, depending on the project. And those projects come at diverse stages and types. Some of the clients are trying to switch to the cloud, while others are trying to use it in the best way possible and need some guidance. For example, how to optimize resiliency or for performance, or how to do security, or how to manage the cost. So what I do with Azure, I would say that I can split the projects into 2 categories. Basically, the first category will be data-oriented projects, where we aim to ingest and store the data in the cloud and make it handy for further processing and to be used easily from self-service platforms like Power BI or from some external applications that are trying to gain some value from the data that we have. So we are using standard data-related technologies like Azure Data Lake, Data Factory, or SQL database signups, and so on and so forth. And the other types of project is the line of business applications, which are basically custom-built applications. And therefore, they use a huge variety of architectures and technologies as they are trying to solve different business problems. And therefore, various services across the Azure portfolio can be used for such projects. And there is a huge variety.
And tell me a little bit more about microservices, distributed applications. What is the specific thing which you need to consider there?
Okay. So microservices are still one of the trendy topics in the software design. This is an architectural style, and it basically says that you have to split your applications into multiple independent services that are independently deployable, which carries with it lots of benefits, and each of them is focused on solving some specific business capability. Like you are getting the entire application domain and you are splitting it into parts, and then you have to figure out what makes sense to be a single microservices or a set of them. And basically each service is focused on solving some specific business capability that's coming from the domain. And each service has to store the data on its own in most of the cases. And things like that. So you might ask, why do we need such architecture? Well, it's for resiliency in the first place. If we compare it with the traditional monolithic architecture, and monolith can be an offensive word nowadays because everyone wants to do microservices. But if we have some performance problem in the monolithic application, it will most likely take our whole application down. But with the microservices architecture, since we are isolating different pieces of code in their independent services, just some parts of the application that is having the current issue will go down and it won't affect the whole business. So another thing is how do we scale them? Because microservices provides you a way to scale a specific functionality which receives most of the traffic. And let's say service A will have 2 instances and service B will have just 1 because it's not really used. But compared to the monolithic architecture, you will have to scale the whole application at once into multiple replicas. And of course, there are some organizational benefits, like if you want to throw more people on the same project, and it's a monolithic one, they will soon start to overlap, and the releases will become very slow because everything should be tested from end to end. And essentially, they are working on the same code base, so it's more difficult.
Do you think that even in microservices architecture, we have also some potential issues? We can have communication between services which can be more intensive that is expected to overload microservices because the internal communication. There are many possible traps.
Of course, as every decision in IT, it does carry some drawbacks besides the benefits that you are achieving. So yes, there can be different types of issues in the microservices architecture. As you said, some parts can overwhelm another, and there can be some internal dependency between microservices. So this thing should be designed very well and requires some even organizational readiness, because you have to manage a lot of things like making sure that everything complies with the DevOps culture and practices. Otherwise, your world will become very difficult, and you will have a lot of problems. And that's the reason why I don't think that any project should adopt microservices, because some small organizations or startups just cannot afford having the complexities introduced by the microservices architecture, because you have to think about how to manage the communication between them, how to expose them to the outside world, what patterns to use for distributed transactions and things like that. And it also can be related to the budgeting side, because if you are implementing a microservices architecture, you will most likely need to have more people at hand. And for startups, it's typical to start with just a handful of developers, like 2 of them are building the whole application. And it feels very much natural to open your IDE of choice and start one project and build it from there, from scratch, without thinking about any complex issues that we might have with microservices. And of course, if you scale further in revenue or resources, or the load increases, you can try isolating some specific parts to separate services until you have a whole microservices architecture.
And what we will talk about today at this event?
Well, yes, the topic will be Dapper. It's called Dapper because it comes from distributed application runtime. And it basically provides you a way to deal with complexity, because in the microservices world, there are a lot of moving parts in a typical application, and maybe you are sticking to certain web frameworks. Each of them comes with some specifics by design, which can also be called opinions. And most of the time, those opinions are what prevents you from making some common mistakes. Like, for example, if you are using some web framework, it has a certain way that you can implement your controllers or routes, for example. However, if you want to introduce something external to the system, like a Redis cache to store your state, you have to figure out a way to integrate it with your framework of choice, like whether it is downloading the specific NuGet package or NPM package, it doesn't matter. You have to find a way to integrate it with your current architecture. And suddenly you will realize that you have built a lot of the same boilerplate code in many of the services using different programming styles and packages. Or even if you want to use a different programming model like the actors, for example, you have to identify a suitable framework like Akka or Service Fabric Reliable Actors or anything other, and figure out how to put it in your application. And that's basically what Dapper helps you with. So are there any other questions, or I can start with my presentation?
So we have not much time, so probably it is better to give this opportunity our attendees to enjoy your session.
Okay, thanks. So I want to say thanks to our sponsors because they are making this event possible. And let's talk about what Dapper is. You can find the official site at dapper.io. So what are the Dapper goals? So Dapper is a runtime for building distributed applications, and it provides the added value via building blocks, which are basically implemented to give you access to the best practices. So you can use Dapper from any language or framework. The thing that you will need to have is basic HTTP support. It's community driven and developed in the open. You can find the project in GitHub. It's called Dapper again. And with it, you can easily adopt standards without dealing with the complexity. Like for example, one of the standards that you can receive from Dapper is the open telemetry. It basically helps you to deal with distributed tracing, because in the microservices applications there are a lot of moving parts, as we said. It is platform agnostic. You can run it pretty much anywhere, but it works very well with Kubernetes. And it's extensible, and you can access different services if you manage to find a suitable component, or you can even contribute one to the Dapper repository. Like, for example, if you want to talk with Redis, there is such a component that will back up the API that you receive from the building blocks. Okay. So what are the application types that can make any use of Dapper? Well, they can really be any application that's even stateless, stateful, or employs some concepts for event running, long running tasks, or it can be a function as a service. It really doesn't matter because it supports different languages and frameworks. You just need HTTP or gRPC. So let's take a look at what those building blocks are. We have a building block for service-to-service invocation, and that is to invoke different services that are running inside your architecture, but via the Dapper runtime by calling the Dapper building blocks for service-to-service invocation. Another example is for state management. Sometimes apps just need to store state somewhere, and you don't have to figure out how to integrate a certain database or cache or whatever in your code. You just call an HTTP API, which is provided from the Dapper runtime, and you persist or get the state. For publish and subscribe is the same. Resource bindings and triggers means that you can talk with external systems. You can even watch them, like, for example, if anyone uploads any blob in a blob storage account, your Dapper application will get notified and it will call the respective services that are interested in performing some actions against that. And if you want to use the actor model, you just need to implement it with Dapper nothing external is needed. And distributed tracing comes built-in with Dapper, and you don't have to deal with it. And there is another secrets building block, which allows you to access systems like or services like Azure Key Vault or the Kubernetes Secret Store. And everything talks to via HTTP or gRPC. So your services can be implemented in pretty much anything which implements the HTTP stack. So as I mentioned, everything is localhost because Dapper basically runs as a sidecar to your applications. So sidecar is a very common pattern in the microservices world when you want to address some cross-cutting concerns and without changing your application code. Let's go ahead. So here we can see how this thing works as a whole. We can see that there are two services, service A and service B, and each of them has a sidecar, which is basically allowing them to connect with the outside world. And I want you to notice that, sorry, sidecars are communicating via MTOS or mutual TOS. So even the communication between those sidecars is happening in a secure manner. And of course, this sidecar that is running side by side with your application allows you to access the building blocks. So you can load and save state, like for example, to Cosmos DB or Redis without implementing the Redis SDK or library. You just call Dapper. So Dapper works with any cloud platform. It can be even hosted privately or on any Kubernetes cluster. But in the Kubernetes cluster way of hosting, we can see that the same sidecar library is present, sidecar container, but this time it's a container. And your application runs side by side in a pod. So essentially you have two containers running in a pod. And we can see that there are several other pods that are providing some helping functions to the Dapper in order to it to function. So we have the actor placement pod, which is for managing your actors across nodes and pods. You have the sidecar injector, which basically injects this Dapper sidecar container into your application pods. And you have the Sentry container, which serves as a certificate authority for your MTOS communication. And also we have Dapper operator, which is managing the component state. Because building blocks are internally depending on components, and the components are the actual implementation of the feature that the building block provides. And this operator has to, whenever it sees some change with the components, it has to notify the Dapper sidecar so it can refresh its knowledge about the containers, its knowledge about the components, sorry. So let's take a deeper dive at each microservices building blocks alone. Let's start with the service invocation one. So we have two services that are trying to communicate with each other, and more specifically, front end is calling the card service. But of course, since the Dapper sidecar is the way to communicate with other services, you have to invoke a certain API endpoint, which in this case is the invoke API, and you specify the name of the other application and its method. And this is the way that Dapper knows what needs to be executed. And this card application received this request on the checkout method and returns its result, and Dapper behaves as a reverse proxy and delivers the result to your front-end application. And for state management, you probably have some application which is called MyApp, and it needs to store its state somewhere. And for this reason, it calls the Dapper sidecar and the Dapper state building block. So you specify the store name, which can point to a state store of your choice, like Redis or Cosmos DB. And basically, Dapper sidecar will talk to Redis or whatever you chose, and it will instruct it to persist this state. So on the other direction, Dapper just, my application can call the Dapper to get some state by specifying the key. So in this example, the key is planet. And Dapper knows how to get it from the state store. So let's take a quick look at the demo, which basically consists of two applications. One is a simple node application based on Express, which is managing some dummy orders, and it is storing them in a state management, in a state store. And there is another application that's implemented in Python that on a specific period of time, it ingests orders. So let's see how it works. First of all, if you want to init Dapper on your machine, I won't listen to music right now. You have to use the Dapper CLI to do this. And that's by calling Dapper init. So it will make sure to set up everything that's needed locally. But I have done this. And I want to show you what things were created for me. So in my user folder, I have .dapper folder, which stores some configuration. And this is basically the configuration of the components that I'm going to use in this demo. So basically, I have a state store. So this is the name of the state store that I'm going to address it when I'm calling the Dapper API. And this is the implementation of the state store. In this case, it's saving the data to Redis, and Redis is running locally on localhost as a Docker container. So as part of this Dapper init command, it managed to set up a few containers for me. Like if I type docker ps, sorry, I have not started Docker. Now, at some point Docker will be up and running. So anyway, let's continue with the other components. If I want to use pubsub, that's the way I define the pubsub component, and that's the way that I define that Redis should be used. And the Zipkin component allows you to basically do the distributed tracing and to see what is going on. We will see how it works. But first of all, let's take a quick look at the Docker containers that are running right now. So we can see that there is one for Redis, which is going to be used for the local, for the state store. There is one Zipkin container, and there is the placement container, which handles the actor placement. But we won't be looking at actors. So let's switch to the demo. So the node application, as I said, is a simple node application, basically implementing 3 methods. The new order endpoint basically deals with persisting the current order to the state store. And as you can see, it's a simple HTTP request, which goes like this. You specify the Dapper port at which the sidecar is running, and you specify that you want to manage state and the state store name. And also there is another endpoint which is getting the current state from the state store. So how do we start this Dapper application? We again have to use the Dapper COI to run the Dapper run command, specifying the application ID. And when we specify the application ID, other services will know how to address our application. So that's the service discovery part of Dapper. Of course, we have to specify the application port that it is running on, and also the HTTP port of the Dapper API. So let's see what happens. Just looking at the logs, we can see that here are the 3 components that were discovered by Dapper, and they will gonna be used. For example, for persisting state. Okay, so how do we call any of those endpoints? Well, one of the options is to use the Dapper invoke, which comes from the COI. So you just invoke a certain application and a certain method, and you are passing the payload data. So when this happens, our node application, which is running in another terminal, will basically output to the logs that a new order has arrived. But we can achieve the same thing by using our browser or something like Postman. Like localhost, we know that Dapper sidecar is running on port 3500, and we want to invoke the method order. And here it goes. We can also invoke the other endpoint via the browser. Okay, but let's see how other services can call your application. So this is the sample. This is the Python application that ingests the data into the Node application, and basically does the same thing. Just over a period of time, it ingests some orders. So how to start this? In the same way, via Dapper COI, but I will need another terminal for this. And if we go back to the Node application, we will see that certain orders are coming from time to time. It's increasing. Okay, so how can we leverage the Zipkin distributed tracing system? So it's currently running in a Docker container on my machine. If I hit just run query, I will see like the recent call to the Node application. And this call was originating from the Python application, and it was going to the Node application. So in this way, we can understand in a better way what is happening behind the scenes with our application. We can also, we also do have an option to visualize things. Okay, was the demo. Back to the slides. So publish and subscribe. Imagine that you want to implement this programming model for publishing and subscribing to something. So the card application here is the publisher, and it calls the publish API of Dapper, and is specifying the topic and what data to pass to it. And Dapper goes ahead and figures out what is the underlying component that stays behind this publish block. And it ingests the data into something like Redis or Nuts or Service Bus. And on the other side, there are subscribers, which are interested in knowing whenever something happens in those topics. So Dapper does the monitoring of, for example, Redis cache for you, and whenever something new is ingested into Redis, Dapper sidecar knows which application to trigger. And we have the resource triggers blocks. So again, we have the same application and sidecar running side by side. And then we have some internal systems that Dapper monitors. And whenever something new happens on them, Dapper is calling the web application, our web application. And resource bindings can be used for output, like when we want to persist something to another external service, or call another third-party services, like sending an SMS as a part of a bigger workflow. Our app just can use those kinds of bindings to communicate with the external world. And again, you don't have to specify to use the certain SDK for that. And those are some examples that can be used right now. And distributed and tracing. This basically happens behind the scenes for you, and it's provided by Dapper out of the box. So open census, you will start seeing it as open telemetry, because they are basically converting it to open telemetry. But that's a standard for doing distributed tracing. And you can integrate with many services of your choice, like Jaeger or Prometheus or Azure Monitor. So how to deal with secrets? Again, Dapper has a secrets endpoint that you can use for storing systems on external secret management services like Azure Key Vault or AWS Secrets Manager. And you just talk with them transparently via Dapper. And in the case of pods, you can use, pods in Azure Kubernetes Service, you can use the managed pod identity to access some certain secrets from the Azure Key Vault. But when it comes to Kubernetes, you can use the built-in Kubernetes store via Dapper. That's another possibility. So yes, apart from being language agnostic and you are able to call it via HTTP and gRPC, it also provides some language SDKs, because some people just prefer to use the language that they are currently writing in to access Dapper. So you have some SDKs built for .NET Core and Go, for example, among others. And there is also some integration with certain development frameworks like ASP.NET Core or functions or logic apps, or even support for virtual actors. So those things are very typical for the IoT scenario and for gaming applications or for gaming backend services, because the way I see it, it's just an object-oriented programming for the cloud. And Dapper has to deal with placing those actors across hosts and pods, and to deal with the distribution and failover. And whenever something goes down, it has to basically move your actors to another available host. So I won't go in details for Dapper, for actors, because we are running out of time. But I want to mention that there is a possibility to integrate Dapper with certain proxies like Nginx or Traffic. And let's say that we want to make an ingress controller and we choose Nginx for our ingress controller. This ingress controller can have a sidecar for itself, and it can directly reverse proxy the traffic to the Dapper sidecar, and then Dapper can work with your other services that can be scaled out. So that was from my side. Let me check whether there are any questions on the YouTube stream.
Thank you very much, Rado. We need to switch to the next speaker, but of course, it will be great if you're able to answer questions in the chat.
Yes, sounds good.
Thank you.
Thank you.
We are now here with Nikolai Penev, who is General Manager of New Horizons. It is one of the biggest worldwide companies for trainings and certifications, including, of course, all Microsoft technologies and certifications on Microsoft technologies. So welcome, Nikolai.
Hello. Welcome. Nice to be here.
Thank you for joining our event. It is very important for us to have you at this conference on Microsoft Azure, because I know that New Horizons is focused on many trainings and certifications on Azure. So it will be great if you share some insights about training, certifications, programs, what you think that will go very soon, and about plans of your company around trainings related to Microsoft Azure.
Okay, thank you for invitation, and thank you for this question. New Horizons is a global company, and Bulgaria is one of leading centers in this network of training centers. Thank you to feedback of our customers, we are rated very good. And our life is dedicated to learning. This is what we do every day. We provide learning services from every IT solution or end users or developers, project managers, and Microsoft is traditionally our first and very important partner. And what can be done can be said for new Azure trainings. As we all know, Azure is one of key focuses of Microsoft. Everything is around Azure. And what we see that recently a lot of trainings start to disappear, and they are replaced with role-based certification and role-based training. This is a little bit annoying for older IT professionals, because they need to start reading and learning again new things. But
sorry for interruption. Could you explain what exactly means role-based certifications? It is important for many people to know.
Yes. In the past, Microsoft training was oriented around specific product and specific version. Few years ago, we see expert series of certification where the version disappear. The guy should be proficient in specific product and technology. Then now we are seeing role-based. This is because companies are oriented more on the results, and the results are depending on the processes They are depending on the team and not specific product. Sorry for interruption, but work from home is always some last-minute interruptions. What is Azure role-based? This is the top change. They are oriented on specific role. One is for administrator, one is for developers, solutions architects, DevOps, and some more specific like data scientist. What can be seen in this huge portfolio? Microsoft created excellent decks where everyone can orient. This is shortcut is here. I will show a little bit later. And this is the life is change oriented to the results, and the results depends on the process within the team and organization.
Thank you very much for this explanation.
And I can show everybody can find on this on internet. There's excellent pages created by Microsoft. And one of these is 95 slides. This is 95 different job role specific learning paths. I will not consume at this time for showing internet page. Everybody can do this by their own, just to show how is the beautiful work by Microsoft done. You can scroll to various different roles, and you can dig in and find what you need. And what can share from our experience in from New Horizons? This is top 5 classes at the moment that are scheduled in New Horizons in globally, and the names can be different in different markets because every market has different maturity. In some, Azure Fundamental is the most popular. In other, Microsoft Azure Administrator. And also very important is architect, because if you build something and the architect role is missing, later on everyone knows what happened. Huge bills and faulty products. And this is what we deliver on market with Bulgaria. We see nice interest to DevOps, Azure DevOps. We see also not only Microsoft DevOps, because the job role is Microsoft play important part, but Microsoft is open company. And another is growing demand for Internet of Things, but it's still very small in numbers to become one of top 5.
So it is very interesting, really. And I suppose you are able to provide trainings for all types of certifications.
Exactly. Most popular is administrator, architect, and developer, but we can also find a solution for security. And of course, in beginning, everybody start with fundamentals.
Okay, that is very important for our attendees. They will know that if they consider to take some certifications, they can ask New Horizons for the appropriate courses, and they will be able to contact you.
Okay, thank you. Thank you.
Thank you very much for joining.
Bye-bye.
Welcome again at Azure Bootcamp Bulgaria. We are together with one of the most attractive speakers who I know, Radi Atanasov. Radi Atanasov this time will present quite unusual for him session, which is related to DevOps, but in the context more of team leads and processes, which is really something which is not often offered from Radi. What I mean, usually Radi talks about very deep technical content. Probably again, we will have some deep challenges, but in a little bit different context. But welcome, Radi.
Hi, hello everyone. Thank you for having me at this awesome online conference.
Thank you for joining. I'm really glad to hear again your Australian accent.
Awesome.
We have no enough time to talk about some interesting things about your story because Radi Atanasov is really a very experienced person who did very interesting things in different regions worldwide. So we will go a little bit more directly into the context of his presentation. So Radi, why you decided to propose such kind of topic?
So, of course, this is an Azure bootcamp, so I wanted to present something about Azure, and in my case, Azure DevOps. And my second aspect is team leadership. I think, especially in our region in Bulgaria, not enough teams adopt industry standard based practices, and they don't have a process that helps their developers get the job done. So I wanted to show some of the Azure DevOps tools that would help team leaders just get up and going, sometimes for free, depending on the size of the team. For small teams, it could be free, with some features that I will show that we use or I use for some of the work that I lead and that I engage my team members with. And I think it's something that's missing in the local ecosystem. So I hope people will find it valuable.
Great. And could you explain a little bit more about the daily job of Dev Team Lead?
Okay, so I've got several slides on the topic, but basically a development team lead is something that's very different from organization to organization, simply because organizations are different. There's a different set of processes that people have adopted and maybe processes that people haven't adopted. So the first job of the development team leader is to either put those processes on the table and adopt them on the or within the daily iteration, or if the team leader doesn't have that say or doesn't have that basic decision-making power, then the team leader can present it to whoever has that decision-making power. Developers are productive when they follow a process, they get into the momentum and they follow a rhythm. And if there is no process in place and there is no tools to govern and manage that process, the development usually is something that lags behind and developers are very, very unhappy. I get a lot of people that explain to me in interviews when I recruit people that they don't have a process. They use tools like SVN or zip files to do source control, no iteration planning, no time management, no reviews, no team leader engagement and time in order to help them develop. So they can't really grow and they can't really get their job done. So this session is about what you can do quick, now, easy, for free, sometimes to just boost your level of performance up.
And it is interesting what Azure DevOps tools you think are most important and useful for modern team leads.
Okay. So Azure DevOps has a long history for all the days from TFS, Team Foundation Server, which used to be more about source control. Then it adopted some task management practices. Then it became agile. It used to have process templates. Now it's online. You can just click start, get an organization. You get many things for free. You get something that's called Azure Boards, which is your task management set of applications. So it lets you define stories, work items, bugs, issues, features, epics, whatever you follow as a process in one place. It gives you Kanban boards. It gives you the ability to basically assign work, review work, and get analytics on that. So Azure Boards is number one. Azure repos or repositories is your source control aspect. It's now fully Git adopted. You still have the TFS version of source control if you like to use that, but you get Git repositories, so you get everything that Git gives you: branches, strategies to merge branches, the ability to execute pull requests, and all kinds of Git source control, version control management sets of features. And sort of to get the process complete, it gives you pipelines, Azure pipelines, the equivalent of GitHub Actions, the ability to do continuous integration, continuous development on the entire process, basically. So it gives you quite a lot. It also gives you test plans, the ability to manage the workload of QA people. It gives you everything you need in order to run a productive development team. And of course, Microsoft use it, they dog food it. So it is a good example of something that you can use to build really highly adopted software at scale.
And you mentioned about pull requests. Can you explain what is for you good pull request process?
Okay, pull request is about a developer submitting their work to improve the product that's been developed. So they change the code base, or they implement a new feature with changing the code. They might fix a bug with changing the code. So they submit a pull request, which basically says towards the team, can someone please have a look at that pull request? So a team member, hopefully not the team lead, but a team member would do a first run of code review. They might have the appropriate time to even test that feature and make sure it is working as per the requirements. That empowers team members to basically leverage one another's skills and hopefully build on one another's skills a bit better. So the pull request is a place where people would comment and collaborate on the code, make sure they follow the standards, make sure they follow the team's rules of quality, make sure they follow the definition of done for the team. And basically through collaboration tools, Azure DevOps does and provides a really awesome pull request experience. You then basically run the policies on the pull request. So you have to run tests before it gets approved. Those tests can be at different layers of the application. So basically your release blockers. If something fails testing, the pull request can not go in. Basically, that's the minimum you could go by in order to have something that you might call a process.
Great, thank you. And probably we can go ahead with your presentation.
Yeah. So I've got several slide decks here to help me basically achieve my task. A little bit about me. I run a company called 1-Bit Software. I started this company 10 years ago in Sofia in Bulgaria. I came from Australia to start this company, so that's my main focus. We have a spin-off called Quantum Software Group where we build a product. 1-Bit Software is typically a services company, and I've done several other things in my background. I don't want to bore you with all of those things. So I'm going to talk about the mythical team leader. We spent quite a lot of time on this slide, so I'm going to skip most of it in order to keep time.
Slides.
Oh, do you not see my screen? You should have told me earlier. So you are embarrassing me. I feel like an idiot. So, okay, this is the About Me slide. You can have a diagonal read of it. So let's talk about the team leader. Different organizations would have different set of responsibilities for a team lead. Hopefully, they know what they want from the team leader. So a job description is actually very, very important in order to make sure the team leader is doing whatever we are expecting from that team leader. If you don't know what you need to do as a team leader, you need to ask. If you're not a team leader and you want to be one, you need to ask what your organization's job description for a team leader typically might be. They might be responsible for some or all of these things, depending on the size of the organization. Number one is process governance. Are the developers following the established process? If there is no process, that's a problem altogether. But if there is one, are we following that process? And number two, are we improving that process? A process on day one is never perfect. A process at day 3 years ahead is also never perfect. So it's a process improvement is an ongoing task of the team leaders or all of the team leaders, depending on how big the organization is. And you'll see that some of the big organizations rely on process improvement or suggestions to come from the execution teams. You might have a set of tools, quality standards, the definition of done, things put in practice in order to support that process. Especially important is quality standards, not only code styles or basically rules of how you do whatever you do. So follow the existing way of implementing things or suggest them as part of the retrospectives and the dedicated time where you have the voice to improve that process. So number one, process governance and improvement. Number two, daily task management review, what we sometimes call as the momentum manager. Is everyone moving ahead with their tasks? Does anyone not have tasks? Are they blocked? Is there something that you can do to unblock them? Whether you're doing a typical Scrum process with a Scrum owner or not, the team leader is usually the person that will actually do the task unblocking, especially if it's a technical task. And it depends on how technical the team leader is as well. Pull request reviews and approvals. Someone has to do that kind of work. It has to be done against the agreed standards of the team, not based on personal opinions. The entire team needs to be aligned with the standards of the team. Assistance, hand-holding, guidance, pair programming, screen sharing, definitely a job of the team leader, especially a technical team leader. Fixing technical issues, again, that might be your senior developers, it might be your team leader. The senior developers might be the team leaders. Different organizations do it in different ways. Measure team KPIs. Usually that is the team leader's responsibility. So how many bugs were raised, how many stories were completed, has the sprint commit or the iteration committed work actually been executed, who's doing good, who's not doing good, and how is the team doing compared to other teams. There's some things in Azure DevOps that can help all that. And for a last point from me, one of the key things of the mystical team leader is empowering the team. The higher you go up the hierarchy in an organization, the less work you have to do. You have to give that work to the team members and do as least amount of work as possible, typical team leader quality. But the key message here is empowering, delegating, correcting, helping, rather than you being the bottleneck of all of the work. It's so often that we see team leaders being the actual bottleneck for work. In Azure DevOps, I'll quickly show the structure of tasks for the Scrum model. In Azure DevOps, we've got epics, features, user stories, tasks. As the books go, a bug can be configurable, whether it's at the level of a user story at a task, and you can have tasks to fix the bug and to test the bug. What we do typically in user stories is we would have several development tasks, hopefully a test task, and all of that depends on how well we actually plan throughout the iteration. An issue is something that needs side attention, might be a spiked piece of work, might be something else. I'll quickly show you our Azure DevOps instance. I hope you guys can see my screen. Can you see my screen? Yes? I hope that's a yes. So in our boards, I'll quickly open our current iteration. It started today. So we do 2-week iterations, so August 31st to September 31st. So there's a small chart here with burn down. There's nothing burned down. We basically have, in this iteration, a whole set of committed bugs that we want to clean up from our product. Some of them are tasks, some of them are bugs, depending on where they came from, how they came from. We've got 4 committed stories, each with a set of tasks basically defined on that story. So this view gives me basically the full view of the iteration in a sort of a task grid level. I can see the hours remaining for each task. I can see the status. I can also have a look at it from a task board perspective, and I can see what's active. From this view, I can see if a certain person has more than one task that is active. Usually gives me indications that they are at the pull request stage, and they would most likely need some review in order to continue. I've got a view of resolved work. And of course, these are grouped by stories. So this is your typical task view. We also have the iteration goal defined here. So with a title and with several details of sub-items that we need to complete. The iteration goal for ourselves is basically a 0 or 1. So it's either a pass or a fail. We have a really nice backlog view that is based on from top down. So epics, features, and each feature follows through with stories or tasks. Maybe tasks are linked to stories, maybe they're not, depending on how well we actually organize ourselves, how much time we spend on this, and of course, whether there is a product owner or a Scrum product manager or involved in the play. So that is basically how we do task management. At a very high level. I don't have that much time to go in a huge amount of detail. The next step that I have is after planning, we do basically the work or the execution. I mentioned earlier that for me, work gets done when you follow a momentum and a rhythm. So we do 2 bi-weekly iterations, so 1 iteration is every 2 weeks. We start it with planning, which is usually at the end of the review and the retrospective of the previous iteration. You can call them sprints or whatever textbook you're reading. Basically, throughout the execution, Azure gives us the entire sprint view that allows me to follow the work. It gives us the actual tools to do the work. Now, when we write code, we do work in source control. So I'm going to click here in Azure DevOps. This is what our solution basically looks like. Git gives us a really good source control management or version control management capability. You can see we use a lot of branches. You can see here the size of the team. In this case, each team member has several branches in action. Some of them are live or being worked on. Some of them are behind. We use branch prefixes for bugs and features. Some teams use bug numbers, and whatever standards you want to follow, be sure to follow. And of course, we've got a dev branch, we've got a master branch, we've got a staging branch. We use them for different purposes. So really good source control based on Git. Next thing I'll go through is pull requests. So he'll ask me how we do pull requests. This is live and it's active. This is real time. For example, we have several pull requests with different statuses. Some are draft, some are in action. For example, let's look at this one. It's set to autocomplete. So this particular pull request currently has 2 validations that are failing, or one that's failing, which means that it cannot go into the dev branch. So this is what typically is called as release blockers. It has a pull request checklist, which makes sure every developer does whatever the team has agreed in order to do that. It's the team leader's job to follow through this, review it, change it. Some of them are a bit hard to define, so does your code follow the definition of done? That helps basically teams agree on what is done. It works on my machine, but it doesn't work on somewhere else. So is it done? Probably no. We've got an impact assessment in our pull request, which basically tells or helps the testers understand what could have potentially broken. This is manual QA assistance to support basically manual regression testing. As much as it could be verbose, it's good. We have basically tests executed from this branch, so short videos on how it's basically working, what problems we have. There's discussions here, there's mentions. Sometimes if work is not to be done in this task, we would typically create a new task out of it and plan it for the next iteration rather than impede the iteration. We were really bad at that. Now we're much better. There's, for example, proper code review. I might as well click the files here. So here we have inline code suggestions. Don't do this, whatever the case is. I don't know what you're going to read here, but it's as actual as it could be to real life. Our pull request validation is failing. We've got a build that's failing on tests. So this is more about Azure pipelines and release management. So I've got a log of everything that has happened. I can see the build process. I can see all of the tests that have executed. And I can see some of the failed tests. I can see the actual exception that has been thrown. And if I go back to the pull request, I can see basically the actual test results. I'll remove some of those filters. So we've got about that amount of tests running automatically. And these are the tests that are blocking a pull request from reaching the development branch. Basically, once they reach the development branch, then we run a different set of tests based on various things. Tests need to be at 100% in order to be accepted and basically put into the dev branch. That is basically what a pull request gives us. I'll just scroll back. We've got the reviewing concept. We've got what bugs are fixed with this pull request, and we have different tags that we can do in order to basically do that. It's in status autocomplete. That's because I have done something to do it that way. So if it's in status autocomplete, if the tests pass, the validation, all of the comments have been resolved, which is basically our pull request policies to merge, it can autocomplete and basically automatically merge into dev. You don't need to do any manual actions in order to do that. At any point in time, I can see when the particular developer has done the actual work. I can see the commits that they have done. So I can track things as how much is it slowing down, how many times are we doing ping pong between whoever's doing the review and whoever's submitting the pull request. I might as well show some of mine so I don't basically piss some of my team members off. Again, same concept here. This is my pull request. I'm getting comments. Am I doing something here? I'm basically discussing those comments or fixing some of the work. I personally like this experience a bit better than the GitHub code review experience, but at the same time, I'm used to it because I look at this several hours a day. So that's the pull request aspect. I think I showed you release blockers. Basically, if we go to pipelines, here we can see all of our pipelines. So we've got pull request validation. I like the fact that it's green. It was very red. So before the meeting, I basically deleted some of the failed builds just so it looks more green. We typically take about 30 minutes to execute pull requests on towards the dev branch, and another 30 to 40 to 50 minutes the actual dev branch builds. We've got 5 pipelines here running, and we also have release management. Release management is more towards the continuous delivery aspect. Here we basically have the agents taking the code base, deploying it to the machines, running several PowerShell scripts, copying files around, stopping Windows services, starting Windows services. Just basically with one click of a button, I could deploy to whatever environments we have, and that's how we do release management for this particular project that I'm showing. I'm running out of time significantly. So iteration progress, the ability to follow the work. Azure DevOps, I think, is lagging here towards some of the tools. Sorry, that's my desktop. Yes, that's me. So Azure DevOps basically gives us basic analytics in the concept of dashboards. These dashboards are very strictly related to the process. So if you do something different, you have to either customize them or maybe even do some kind of custom development. In here, I can see the status of the iteration. Because it started today, there's no actual work on the burn down. It will update itself tonight. But here I can see who's got what number of tasks. I can see a 10-week summary of whether we're burning work down or we're actually building up more work and more work and more work, depending on how we manage that. There's several things I can see. I can also have an overview of the actual team and how things are going, who's got what amount of tasks, the amount of tasks that I have assigned to me. Usually when there's more than 10 tasks, that's a warning sign, which means that everything's not being delegated for me enough. There's definitely some metrics here that you can make use of, and hopefully gives you enough insight information. There's also a new aspect called analytics views. I haven't spent the time to configure this, but that gives you some of the out-of-the-box views that really help team leaders basically measure the KPIs of that team. So bugs, stories, tasks, basically work item summaries, in order to help team leaders basically keep that wheel of momentum going. I've got 5 minutes and then 5 minutes for questions. This is just a quick screenshot of the iteration view. There's a lot of things that I actually do outside of Azure DevOps, so get some of the information out and just look at it manually. We would either do it in meetings or whatever we need in order to basically get more insight out of it. In terms of the end of the iteration, what we would typically do is have a review meeting where everyone performs a demo of their tasks, hopefully at an environment that is agreed to have that demo. So we don't have the typical case of it works on my machine. We don't want it to work on developer machines. We want it to work on target environments. It's different for whatever software you're building. So how many tasks have been completed against the definition of done? Is there something that's unfinished or spiked or blocked? Basically, everything that's reviewed as part of the iteration, we typically do it at the end of the iteration. Key decision, is the iteration goal met or not? So if it's not met, then is the goal not set right? Are the expectations incorrect? Is there something in the process that is not good enough? Different teams basically plan this in a different way. Some of our teams always fail them. Some of our teams always make them pass. So it depends. There should be an equal set of standards across the team. Several other aspects during review and planning. You can go to bug jail. So if you've got too many bugs, you can't commit any features until you've fixed all your bugs. Typically in review, we look at dead pull requests, and you can see some of our pull requests are actually dead. So if we go to pull requests, some of these have the on hold status, which means that we've committed to work that's not important and we don't need that bug fix, or we are suggesting a change that is too difficult for the QA teams to basically take, test, and include this. So basically something with lower priority that requires coordination and effort that's not typically planned. Metrics, yeah, the typical things: velocity, stories committed, stories passed, bugs raised, bugs failed, Bugs failed means you've submitted a fix to the bug, but the fix fails. Those always raise alarm bells. Have you committed to work that you have not completed? Has to look at. Unfortunately, we suffer from that. We commit to work that we can't do because we love our job and we want to do everything. We love our product. So, but we have to keep things real. The retrospectives, with the team that I'm working in, OneBit Software has several projects, several teams, several products that we do. So the team that I lead, we're not doing a good job with retrospectives. I'm not getting much input for improvements from the team. Usually I have to put them forward, which highlight several aspects of problems within the team. I've always said that the people who speak and suggest what to change and what to improve are the people that drive change. So there's several things that you can do to empower basically people to suggest improvements, and the team leader's job is to commit to follow those improvements. If someone gives you 10 improvements, you should only commit to 3 for each iteration, but you should get those 3 things done. And the last point, of course, is planning is the time to do team empowerment. Give the ability for the team members to shine. A team leader's job is not to shine on top of the team. It's basically to support the team to shine. So that's what I have. Some of these are team leader-based management theories and practices. Some of those are basically Azure features that let us do that work. And of course, we use Microsoft Teams. We're a remote team because of the whole virus situation. So here you can see stuff. Some of it's in Bulgarian. We've got Azure DevOps integration, so you can see the pull requests. So you don't have to basically, get emails and look at your mailbox. I like to keep my mailbox empty. We've got several integrations with Azure DevOps. So the backlog view, it gives me quick access to the backlog. I've got views to the dashboard so I can look at that stuff. Takes a moment to load sometimes. I don't want to wait for it. And of course, the pipeline view, continuous delivery view. I actually put those in Microsoft Teams before my session, but I use it from here. I just did it because it's cool to have tabs in Teams. So I've got 4 minutes for questions. I've got a questions slide. There's my email. You can email me if you want. Basically I will open the floor to get some talk from you guys. Mikhail?
So thank you very much for this awesome presentation. I suppose that after the presentation, you will be able also to collaborate with people who watch our presentation in YouTube and to see if there are some questions to answer these questions. It will be really very awesome. Thank you one time more, and hope to see you again at the next event.
Of course, I'd love to be there.
Great. We are again at Azure Bootcamp Bulgaria with Martin Tatar, who is Microsoft Community Program Manager for CEE, Anton Boyko, who is Microsoft Azure MVP and Microsoft Regional Director, and Ivan Donev, who is Data Platform MVP, Data Architect, one of the most popular community people in Bulgaria. So welcome, guys.
Thanks.
This is an unusual format where we try to have event more interactively. So it is the first time. Hope that you will enjoy this format and will provide this important feedback for us after the conference. So Martin, my first question is for you. Actually, it is not just question. More, I would like to ask you to share some impressions about Azure community in our region. You're community program manager, so you know everyone who work on Azure in our community here in Central Eastern Europe.
Yeah, you put me on the spot. That's a tough one. No, I enjoy working with all the MVPs and the regional directors. So my name is Martin Tatar, and I'm one of the community program managers for Microsoft. To answer your question, I was last time I visited Sofia, Bulgaria, was actually for the Azure Bootcamp and AI Bootcamp. It was also Microsoft 365 Bootcamp. It was all three in one, and I got to meet Ivan and Michal in person. And the community was really strong. I think we had around 150, anywhere between 100 and 150 throughout the day people. So I was impressed by the attendance. It was a one weekend before Christmas. It was a Saturday, and many people were there. So community is strong in that aspect. I enjoyed seeing people that were also non-Microsoft, friendly at the event, but they were Azure friendly, if you will. So in terms of the community in Sofia, very strong. And I can say the same actually for Kiev, because we have Anton here. I got to visit him and experience the same thing. So very, very positive mindset and landscape.
Great, thank you. And Anton, you're one of the people who worked from a long time, probably 10 years on Azure. And do you see any changes in the community during this long time when you actually drive this community in Ukraine and the whole region?
Yeah, actually, I see a lot of changes because I always, like to tell this story that when we just started, like more or less 10 years ago, as you mentioned, when we just started, we run a lot of trainings, and they usually look like that. So we actually gathered for like 2 days. That was usually like weekends, and we put like a slide with maybe like 9 or 10 blocks and said, hey guys, this is Azure, and for these 2 days we will teach you everything that we have in Azure. And I do believe that currently I can spend 2 days just trying to name all the services that are in Azure right now. So definitely the changes were huge. And what I can see is that if like 10 years ago, it was, like mostly for the, let's say, startups, for those who are not afraid of, let's say, creating something from the scratch, re-architecting the whole application to be more, let's say, cloud native. Now I see that the changes were made in a way that Azure is more available for everyone. Like now it's more, let's say, oh, I will just made it this term right up, but anyway, it sounds quite fancy. So it's more less cloud native. Let me try to explain actually. So I mean, like currently, the Azure is more friendly, so you don't need to, like spend a lot of time by doing this application really, really kind of Azure specific. So you can utilize all your knowledge that you already may have working with other cloud providers or working with on-premises application and just move your app to the cloud and then continuously improving it. But that basically gap between, like moving your app to the cloud. Now it's much more narrow and it's almost gone. And this is what I actually also enjoy about Azure. And it also took a huge effect on the way how our community basically operates here. Because currently, and this is actually the format that we will try to pilot this year, and I'm not afraid to say to this group as well, is that we want to try to do something like an open mic, when basically everyone from the community can came and share his story, because we do have a lot of experts, and to some degree they're like afraid to share this knowledge, and we want to eliminate that as well. So yeah, this is about it.
There is another interesting thing. In the past, Azure expertise was related to two categories. Developers who work on Azure, mostly these people, if they are active, stay Azure MVPs, and platform engineers who work on Azure, like administrators, and they usually stay in the past cloud and data center MVPs. But now things are changing because everything is in Azure. Data platform is in Azure, AI is in Azure, and everything is in the context of Microsoft Azure around Microsoft technologies. Ivan, how you think about these trends and changes which are related to data platform, BI, AI?
Yeah, well, I'll have to kind of start slightly earlier. Back in the days, if you're in the data world, you are starting like either a database developer or database administrator, which kind of relates to what you already said. And if you were good at one of those things, it was very difficult to be good at the other or bunch of other roles. And then all of a sudden, cloud started coming in. And I have to say that regarding data, I don't know if it's a couple of years back compared to the development technologies and stuff, but definitely there is a huge switch towards the new roles that are there in the cloud. You no longer have to think of, okay, what kind of servers, how much storage will I need, who's going to access that environment, how I'm going to do the whole dev test prod cycle, and so on and so on. And then all of a sudden, this becomes like the new normal, where you click a couple of buttons and then you have all your platform and all your units available for you. And the only thing you need to figure out is, okay, so how do I connect the different dots? And now this becomes the new challenge, actually, what I see around the trainings that I do and the different projects. How are we actually going to figure out which thing or which piece of service is going to do the best out of what our task is? And the more I work with Azure, the more I kind of figure out, okay, so I'm thinking it like that. There's always going to be version 1, but there's also going to be version 2 and version 3 and version 4. And it's no longer this monolithic approach that you need to use. Okay, we start with SQL Server 2012, and for the next 5 years, we're going to sit there. No, and I see that it's really easy to switch from one, let's say, type of architecture, transition to another one, or choose to use another service. And it's so much easier and, of course, challenging, because nowadays the database guys need actually to constantly learn how it used to be like 5 or 6 years ago, when all things started for developers, or 10 years ago. And another challenge, now DevOps is also coming to the data platform end. And that's something probably most of the guys that work with SQL Server and reporting on premise, for instance, are kind of terrified, because they probably have never done it. And all of a sudden they need to handle all this CI/CD, DevOps, version control, and all these kind of acronyms or processes that might not, let's not generalize it, but might not be their normal way of work through the years.
Absolutely agree with you. We even had such kind of presentation, if you remember, a few months ago. Martin, how you consider community events in the near future in the region? I mean, what kind of format you think will be the most convenient? How you can explain what you want to see here?
Yeah, you're giving me all the tough questions. I'm actually going to turn off this fireplace. I'm actually at the office. It's not a nice vacation in the mountains, unfortunately. So I'll make it a little more, I guess, interactive by moving. But I wanted to touch up on a couple of points quickly to answer, to touch up on what Anton and Ivan said, and then I'll also answer your questions. I took some notes. I really agree with Anton on the easy access to Azure, especially with Docs and Learn. If you go to docs.microsoft.com or learn.microsoft.com, really anyone can start. The basics, it's easy to access information, it's easy to do the basic certifications, and for the beginners, it's really become easier in the last 2-3 years to understand and touch Azure. And just like Ivan mentioned, the flexibility there is you can spin up resources yourself, and then there's constant agility and multiple ways to do things. And I like what Ivan says with training people on knowing what's the right path to take. Sometimes I struggle with that. And also the open mic idea that Anton had is a good idea. And that's kind of answering your question. I don't really have an answer on what's the ultimate format going forward. I think that's the question we all ask. I could see it being in more of a virtual reality, augmented reality space where we're all together. But that's maybe too dreamy right now with the current infrastructure in place that everyone has. So just really smaller scale events, open mic, more interaction, and even a couple sprinkled large events across the board. Like we're going to have the Tech Sylvania big event in Romania. That's all going to be all online in 2 weeks that I got invited to today. That's exciting. So big events like that, and then small meetup events to keep the community feel. And hopefully soon we'll start coming, together face to face. We'll see. But as far as the community health, it's still there. It hasn't dropped. I would say it's linear. So we're holding on, and thanks to people like you, keeping it together. We're here right now. So don't have an answer, but hopefully a little bit of what we're doing now, plus maybe a little bit of the old and some new stuff that someone innovative will bring. Might not be me, but maybe.
Yeah, my question was mostly in direction when we have virtual events. The major missing or challenging part, it depends how it is organized, is the social part.
Yeah.
But we need to have this social part to know each other, to have a community. So this is probably the most challenging.
Correct. So in small scale events, like 20, 30 people, it's nice to have like scavenger hunts or like little quizzes to be able to win like $5 maybe Netflix or Microsoft movie gift cards or YouTube Red gift cards. Small little quizzes or icebreakers, those help. But it's a challenge, like you said. So
we will see. We will have next events, and probably after a few months, it will be much more clear for all of us how we can manage for virtual events better the social element. And what you would like to wish to Azure Bootcamp Bulgaria attendees?
Well, I'll go, and then I'll make sure Anton and Ivan get to say something. But I would just say, keep your spirits high, keep your curiosity high, keep browsing the internet, the interwebs, and looking for information, and keep the questions coming either to me or these guys. So just stay active, stay happy, and we'll get through it.
Thank you. Anton?
Yeah, basically the same. So I do believe that still, despite the kind of lockdown, you need to be positive and you need to keep yourself safe and focus on your family safety as well. So yeah, basically want to join what Martin said and wish everyone to be safe. And I will also jump to my next session right now. See you guys.
See you, Anton.
See you.
And
I guess it's my turn. Well, be safe. I mean, that's like the traditional these days, but you know, it's kind of different for everyone. But do whatever you need to do to keep sane, to learn new stuff, and use this as an opportunity to have all this additional time for yourself or for your close ones. And at some point, we'll definitely still be able to see each other, drink a beer or two, or even more. But of course, until then, again, be safe.
Thank you very much, guys, for joining and support this event, and hope to see you soon.
Thank you so much. Thanks for inviting us. See you soon.
Bye. Bye-bye. Then let's rock.
Okay, so I hope we are live. So hello guys, and I do believe that this is one of the last sessions on a global. The last one. Oh, cool. So this is the last session on the Global Azure Bootcamp Bulgaria this year. But anyway, welcome to the last session. So, and that's me here, Anton Boyko, live from Ukraine. I do hope that you can see my face. Probably most of you even remember me and know me in person. And on that point, I actually want to turn off my camera and I want to actually switch to sharing my screen, sharing my presentation, because in that way I do believe that the quality of the streaming will be better. So yeah, let me share the presentation now. I hope you can see it on your screens. Can you see it?
Yes.
Awesome. Okay, so we have our time here is basically limited, so I will try to share everything that I prepared for this session. So the name of the session is Azure DevOps Quality Gates and how to deliver the apps with the predictable quality. My name is Anton Boyko. I'm Microsoft Azure MVP, and starting from this year, Microsoft Regional Director as well. Here is my email. Feel free to write me and ask any questions you like. And also, there will be some links at the end of the slides, and I will share the slides with the organizers. And those links, they will basically they will navigate you to some extra information and also the source code of the few examples that I will present today as well. Okay, so now let's get to the topic. Quality gates. So if we are talking about quality, especially in a software development, let's talk a bit about quality assurance in general. So when we talk about quality assurance in general, that usually looks like this. We do have a practice of continuous integration and continuous testing, and you pull your source code from the repo, you build that source code, you run some automated tests, and that helps you to accelerate delivery. This is the repeatable process. You can optimize the resources and stuff like that. So this is basically all those stuff that we already may have, or at least we are pretty good aware about those. And now let's take a look at one simple example. So let's say that this is my code. I have some controller which just basically calculate the sum of two numbers, and this is the test for this controller. So the controller is super simple and the test is super simple. And this test, this is basically the unit test. It can run independently, and everything seems to be perfect except actually one issue here. It's not like an issue, but let me just explain what I mean by this one. So we do have those attributes, and without those attributes, if I will remove those, if I will remove line number 1, line number 2, and line number 5, my test will still be valid. It will be still green, but the functionality will be broken. So the idea here, what I want to say is that it's not like you need to test the implementation of Microsoft ASP.NET library. No, it's not about that. It's more about that when you create your app, you create your own code, but there are a lot of different, like angles, a lot of different approaches, how you can address the quality assurance of your app. And we were talking about the unit testing, but there are much more of those. There are integration tests, the end-to-end test, the performance testing, and stuff like that. And the idea is that when we talk about unit testing, the unit tests, they usually can run, like in the sandbox environment basically everywhere. But for example, if you want to run end-to-end test, in that case, or like the performance test, same basically here, if you want to run those guys, you need to deploy your app somewhere. And then only after the deployment, you will be able to check your applications for those attributes, like the performance, for example, as I was saying. So that basically means that we also came a bit closer to the practice which called the release automation. And this is how it usually looks like. So you basically pull your code from the repo, you create a deployment package from this code, again, automatically, and then you have this kind of a set of train stations, you can call it like that, the dev, the stage, the production, and so on and so forth. And your release, it basically travels from the dev to stage to production. So you deploy it on dev first, then on stage, then on production. And now when you deploy actually your application on some environment, you can run some automated tests and you can check, for example, is it okay to push this version of my application to the next environment or not? And if we are talking about Azure DevOps, and here we're talking about both actually the Azure DevOps service and also the Azure DevOps server, which is on-premise solution. So there is a functionality called the quality gate or quality gateways. And how it actually looks like in general, the concept itself, you have your release pipeline, like a huge long release pipeline, and you have the set of stages, which usually represents your environments. So let's say you have the first stage, which called dev, and you have a part of this stage which is responsible for deploying your application to this dev environment. And in addition to that, you have on the left and on the right side of this train, and as you can see, this train, basically the release pipeline train, it always go from left to right. So it's always kind of one-way train. So you have the first part, and actually that's, I do believe, the simplest implementation of quality gateways, but still that's most wide used implementation of the quality gateway. It's called the approvers. You have the pre-approvers and you have the post-approvers. And in addition to that, because the approvers, we're talking here about human beings and the manual approval process, in addition to that, you also have the automated gateways, also as a pre-approve and as a post-approve. And this is valid for each basically stage. For example, after the dev stage, you may have the QA stage. And again, you have some part which is responsible for the deployment. And you also can configure the pre-approvers and the pre-gates and post-approvers and the post-gates. And you configure them completely independent of each other. So let's just basically check how it usually works in a flow, and then we will get closer to basically the exact demos that I want to show you. So let's say that this is basically, this chart represents our release pipeline, and we always start with the dev environment. So this is how we usually implement this in especially in the big enterprises. And this approach, of course, that's not like one size fits all. It's more about the usual flow which we implement, and then we can tweak it based on the exact project, the exact business domain, and stuff like that. So we always start with the deployment to the dev environment. So anyone can trigger new release, and that release will be deployed to the dev environment. And then the dev lead may need to pre-approve this release, which goes to the dev environment. So this is the manual approval part, and the dev lead, that may be one person, or that may be kind of a group of a few people. So at least one of them, for example, may need to give his approve to do that. And why is that? Because currently that may be another version which sits on dev environment, and that version is currently maybe under some, kind of checks, qualifications, checks or validations from the dev team themselves. So the dev lead needs to pre-approve the deployment. As soon as the deployment is approved, the deployment will start, and the new version will replace the previous version on the dev environment. And as soon as that testing on a dev stage is done, the dev lead will basically approve that, okay, now we can share this release with the bigger crowd. So now we can push it next, more to the right side. And the next environment is a QA environment. So on a QA environment, again, the QA lead needs to pre-approve the deployment. Why that? Because currently they may, test the previous version of an application, and they don't want, they don't want your deployment to interfere with their current work. And again, if QA team is happy, then the QA lead needs to say, okay, I basically allow this release to travel further to the next environment, which is demo environment in our case. What is worth mentioning here, that if you never actually worked with the Azure DevOps pipelines and releases automation, the key point here is that for each and every release, you have a unique ID. And to this unique ID, also you assigned all your built artifacts. So that basically means that as soon as you will test this version, you will be able to say, okay, this is my release, for example, version 15, and it consists of, let's say, 10 microservices, and each of those 10 microservices has its own versioning. But under the release version 15, I combine all those versions together. So I can easily have this traceability, and I can easily check what are the differences between two environments. And in addition to that, the QA, that's, let's say, mostly the environment that we use for the manual tests. We also have two other environments that we have here. That's the performance environment and the security environment. So, and here, meanwhile, on those two environments, on the performance and on security, we usually create them ad hoc, because we don't need those environments to, stay for a long time. For the performance environment, for example, we may run our performance test for 4 hours, and after that, the environment can be easily deprovisioned, basically to save money on that. And the same goes with the security environment. We may run some security tests, some basic penetration tests, and stuff like that. And again, both of those environments, they are created ad hoc. And as soon as testing is done on those environments, we integrate the results of those tests to the kind of report that then will be able to used by either QA team or basically everyone else who works on this project. But mostly it's used by the QA team in our case. And also what I also mentioned is that as soon as we are done with the performance and with the security testing, those two environments will be deprovisioned just to reduce the costs of those two environments. The next environment is demo environment. The demo environment is usually owned by the product owner, and the demo environment, we also can consider that as an UAT environment. And again, as soon as the product owner basically approves the deployment to his environment, he will be able to test the new app. The idea here is that the product owner usually shares this environment with a lot of other stakeholders. And if both, if both groups, the product owner and the group of stakeholders happy, we push that even more to the right. And then staging environment, which is owned usually by the AT operational team. So they can, for example, check the deployment process, the rollout process before they will deploy to production on a staging environment. And as soon as they are happy, as soon as they will find a window to release that to production, they release it to production. And in addition to that, they also may release it to the DR later. This is in general how this flow works. So now what I basically show you here, I show you only how the manual approval process work. But it may be, as I was also saying, that we need to run some other things as well. Let's maybe roll back a bit and talk about performance. So I was saying, and this is completely true, that usually if we run a performance test, we may run it for 4 hours. And the reason for that is that, for example, there are also a lot of differences in the performance testing itself. So we may want to do the quick stress test on an application. We may want to run the endurance test on this application. We may just, want to check how this application will perform under the different loads and stuff like that. So that is why we need this test to run for the 4 hours usually. And you can say that, yeah, but I have my pipeline and I can, for example, trigger this performance test from the pipeline itself. And then the pipeline will just sit there, wait for this, long and extensive test to finish, and then just grab the result and incorporate basically that result into the final report about the performance. And technically, you will be right. And technically, in that way, that will be even more easier for you to implement because you don't need to, learn nothing about the quality gateways, and you don't need to implement those quality gateways. And this is true. But there is also a very important thing here is that while your pipeline is basically sitting there doing nothing for 4 hours straight, it can't handle all the other jobs that may happen. So this is basically the issue that we are trying to solve with creating those quality gateways, is that we want to offload the pipeline as hard as we can. And again, let's talk about performance test. The thing that we use for performance testing, we usually use the service called the Blaze Meter. The Blaze Meter, that's basically the cloud service, which allows you to create basically any amount of users. As soon as your credit card can handle that, it can create any amount of users, and those users will start hitting your website. So the idea is that how we usually implement that, we deploy our app, for example, to this performance testing environment, and then our quality gate will actually trigger the Blaze Meter test, and then the quality gateway itself will wait for that test to finish. The quality gateway will basically sit there and wait for the callback from the Blaze Meter, and that's it. And our pipeline will also kind of release this agent, and the pipeline will also wait somewhere like in the shadows, will wait for the callback, and during that period, it can run other builds, other releases, and work perfectly. And then as soon as the Blaze Meter is done, we will receive the callback from the Blaze Meter, and the pipeline here will continue. So this is the usual scenario, how we handle that. And what I also want to show to you before we will basically switch for the demos is that let's talk about two scenarios which we usually implement, or like not that we usually implement that, the two scenarios that you can usually implement your custom gateways. So scenario number one, that's the simple custom gate. And in that case, you have your Azure DevOps, and your Azure DevOps pipeline will basically pull all the artifacts. As a second step, it will deploy those to the web app, for example, and the web app may start to report some metrics to the app plan, and then you will understand that, okay, this app is actually deployed, up and running, and then you may have something which in my case is an Azure function. And the quality gateway, one of the implementations that you can use, that's called invoke Azure function. So you can invoke that Azure function, and then the Azure function will reply back to you with the result of these quality gateways. So you can also think about that as a synchronous quality gateway. And by synchronous, I mean like that you basically send a request and you wait for the response. And in that response, you always get the result of this particular quality gateway. So this works fine, but as you understand the HTTP protocol, usually you are limited to, let's say, short running tasks which can run quite fast and report the results. So I will not recommend to implement this simple gateway for tasks that needs to run like longer than a few minutes. If you need to run something like a performance test in our case, which may run much longer than a few minutes, then the second part will be to implement a bit more complex custom gateway. So the first half is the same. So you pull the artifacts, you basically release those to the web app, and the web app starts to report some metrics. That's fine. But then you invoke the external API, but now you change the type of your gateway. And the gateway will basically receive the request, and it will send back the response that, okay, the request was received. So the task was queued. And then what you can do on the step number 5, for example, you can queue on your end some long running task. And as soon as that task is done, you basically can, at the step 7, report back to the Azure DevOps that the task is done and queue the results. So let's see how all those parts are actually work in action. I will exit the PowerPoint and let me start with the browser. So I hope you can see my browser here. So what I have here, I have the Azure DevOps test project, which I created. Let me go to the pipeline, let me go to the releases, and let me go the first release, which I called the approval release. So what I have here, I have the set of stages, more or less as I showed you in the picture, that can be dev, QA, UAT, and then prod and DR. And on each of those stages, I can click here and I can say I want to enable the pre-deployment approvals. And here I can either put a username or a group name. And also I have some extra configurations here that, for example, the timeout, the 30 days, it means that if in 30 days no one will give its approval to deploy to this environment, then it will be considered as a rejected, and the deployment will be considered as a failed deployment. Also, I can say that the person who actually queued the release should not approve that release. So, I mean, like all those options, I have them here. And this is actually worked in a way. Let me show you here. Yeah, so this worked in more or less this way. So this is the release pipeline that I triggered. So I have dev environment, and as you can see here, I have the green check mark that post-deployment was approved and the pre-deployment was approved. And what I can do, I can click on approve button here, and I have a few options. So I can either approve or reject it. And let's say that I will approve it. I will approve it, and now it goes to the next quality gateway and it's pending approval again. And the difference, and what I really like between, for example, the post-approval and the pre-approval, is that on a pre-approval, I can also say, okay, I want to defer the deployment for later. So that basically means that, for example, if you want to deploy it, I don't know, at midnight, so you don't want to interfere with your business users, you can say, okay, guys, I give my approval now, but let's deploy on midnight. Or you can also reassign this. So this is a really cool feature to have. And in addition to that, let's take a quick look on what we have for the more, let's say, automated quality gateways. And before I will show you how it looks like on Azure DevOps side, let me probably open the Visual Studio Code here, and let me show how it actually works here. I will also zoom this guy a bit so that will be easier for those of you who see me online to follow what I'm showing you here. So this is the very simple Azure function. This is the HTTP triggered Azure function, and I have only one function here. So this is how you implement the simple quality gate. And this is how it looks like. So I set the authorization level on the function, and I will react on a post event. And basically here, I do some login. I want to log the query string. In my case, I want to log headers as well. What I also did here is that when I create the array of my headers that I will put to the log, I just kind of iterate through all of them. And I said that if I will find a header which called the aus token, I will just replace its value with basically some dots or other symbols just to hide my aus token. And I will show you later why it's important. I also pulled the request body, and I also want to log the request body. And then I wait for 3 seconds and return the HTTP OK result. So this is the implementation of this quality gateway. So what I want to do now, I want to switch back to the browser, and I want to create a new release. And while that release is created, let me jump to the previous release. And this is basically how my previous release looks like. So as you can see, I have two environments, blue and green. And this gateway passed here, the post-deployment gate, and the post-deployment gate also passed here. So I can click here, I can see that that was the simple gate 01 and also the complex gate. So both of them passed. And let me just show you how I configure those. So here, the post-deployment approval option, this is for manual approval, but for the automated gates, I have this gates section. I can add, and as you can see, there are a few different implementations what my quality gateway may be in this case. And here we're talking about simple gate 01. So what I actually have here, what I need to configure to add the Azure function as my quality gate. So I need to put the URL of that function, and you can see it here. Also, because I said that this function will use the function authorization level, so I also need to provide the function key. I can choose which HTTP method will be used, and in my case, I used post. And in this way, I can assemble a set of headers. Let me zoom it a bit. I assembled the set of headers that I will basically pass in that HTTP request. And those headers, as you can see, they consist of some system values that may be needed. And also, if needed, I can set the query parameters. In this case, I set two of them, location equals Azure and name equals Azure DevOps. And again, if needed, I can also assemble the payload in the body. So this is really cool. And let me go here. And on the Azure portal, let me just open this function and go here. So this is the execution list. And let me just open this one. As you can see, this is my logs. So function started. This was my query string code that stands for the Azure function code. Location equals Azure, name equals Azure DevOps. Here is my headers, connection keep alive, la la la. Here is my OS token, which was hidden. And here is my body. So, and if I will go here to release number 8, it's already done. So those gateways were pretty fast. What is also important to mention is that here I just reply with HTTP OK from this function, but in case you want to reply with the more complex message, with the more complex payload, you can also do that, and you can configure that in the following section. So let me just show it to you here for the simple gate, what you can do, and I will zoom that in a moment. So here you have success criteria, and oh, wait a sec. Let me do it like this. Yeah. And here is the example how you can craft that expression for your success criteria. And analyze, for example, the detailed results of your quality gateway. Because I mean, like currently, if that field is empty, then my quality gateway will be considered successful if I will receive HTTP 200 code. But if I want to, as I was saying, provide some more detailed breakdown, like for example, HTTP 200, which means that the gateway was kind of triggered successfully and finished successfully, but then I may send a response back that status equaled failed. So it means, for example, that the gateway completed successfully, but it kind of prohibits the application from being deployed to the further environments. And a bit more complex example is how you configure your complex gateway. And the fun part is that from the configuration part, the only difference is actually here. So under the completion event, you have either API response, which I had for my previous gateway, or you have a callback. For a complex gateway, you set callback, and that's basically it. And let me show you how the implementation looks for the complex gateway. And as I was saying, all those examples you will be able to find. I have links to those source codes at the end of my presentation, and I will share that with all the attendees. So this is the first part of the implementation for my gateway, basically. Let me just hide this guy. Yeah. So what I have here, I have the function which I called complex quality gate begin, and this is the HTTP triggered function. So again, it reacts on a post event. It also has the function authorization scope. And what I basically do now, I also create my own custom class. So this custom class, it actually defines how your, let's say, how your tasks for your specific quality gateways should look like. I mean, like what are the attributes of that task? So let's take that example again with the performance test that I was using before. So if you are about to run the performance tests, then what may be the attributes? For example, that may be the URL of the website that you need to use to run those performance tests against, or something like that. And all those parameters that you may need, you need to implement them in this custom class. In my case, I implemented, as you can see, all the query parameters, all the HTTP headers, and also the raw body is also here. That's basically it. Okay, so let's get back to this guy. And here I assemble my parameters. I just basically pull that data from the HTTP request itself, and then I create a cloud queue message. I send that message to my Azure storage queue, and as you can see, I return the results back. And here is the second part. I call it complex quality gateway end. This is another function which is triggered by the Azure storage queue. So it gets, let me just hide those. It basically gets this message, it deserializes it, and then it performs some extra actions. So let's do the following. So let me modify this guy. Let's say await task delay. Let's wait for 10 seconds. Or you know what? Let's wait for 30 seconds. Why not? So I updated this one. What I also want to do now, I want to republish my Azure function. And why I actually want to do that? I want to do that so I can run the new release and I can show to you that at some point that gateway will be in this, like interim in progress state. And while it'll be in this interim in progress state, our long running task can actually run. And this is the usual pattern how you implement that. You can also implement that if we're talking about Azure. You can also implement that with something like an Azure durable functions. It will work the same. So the big idea of this example is that you get the request and then you return the response immediately, and then you can do your job. And I also will show you what you need to save to be able to do the callback later, and also notify the Azure DevOps that you either succeed or failed. I mean, like your gateway either succeeded or failed. So let me get to the browser again, and I will create a new release here. It will wait for the new pipeline, but I want to open this guy. So as you can see, I have these two quality gateways configured here. The pipeline basically is empty. Yes, so it will jump to this one. So as you can see, this gateway actually responded quite fast. So it succeeded. And this gateway, it's in progress state. And in 30 seconds, it will, I hope, be green again. So let's get back to the Visual Studio Code. So I will show you what you basically need to do to send back the callback. So first of all, you need to assemble the URL, and you need to assemble this URL based on the parameters that you actually obtain from the Azure DevOps initially. So if you remember, I showed to you all those headers that Azure DevOps will send to you, and those headers basically contains properties like, like plan URL, the project ID, the hub name, and the plan ID. So you need to use those properties according to the documentation and this format. So now you assemble the link, which you will use basically to report back to Azure DevOps about the results of this quality gateway. And this is the URL. The second part is the body. So you actually can assemble that body in a different ways. And the idea is that in my case, actually, I use the message or like the type of the event that I send back to the Azure DevOps, which called task completed. There are much more events, and I have the link to the detailed documentation at the end of my presentation. There are much more events that you can use. For example, if you have a really long running task, you can periodically send some logs. For example, that yes, we are like still alive, we're still doing, we're still checking something, so please stay tuned. Like just to show to the person who may basically sit there and check what is actually happening, that there's actually some useful load or useful computation that is happening right now. So for this task completed, so it's basically you have like 3 mandatory parameters here: the name of the event, the job ID, and the task ID. So the job ID and the task ID, you get those guys again from the headers. And specifically to task completed event, you also have one extra property here called the result. And it can be either succeeded or failed. And based on what you will put here, it will basically send the appropriate event and say that your gateway either succeeded or failed. And then what you basically do, you just create a regular HTTP client. And of course, it's not like anyone can send the data back to Azure DevOps and basically any person in the world can interfere with your pipeline. You also need to provide an authorization token. And the authorization token, as you can see, that also one of the headers, and that was the reason in the first place why I hide those headers in basically my in my example, which I showed you before. That was the reason for that. So let's get back to the browser. As you can see, those gateways are green, and we were able to proceed further. I know that was fast, but anyway, at that point, I'm at the end of my presentation. If it was really fast, sorry, that's because I had a lot of content. So as I was saying, I do have some links here. So this is the link basically when you can check a bit more information on how to configure the manual approvals. Here you can basically check on some extra information how to use those approvals as a part of your release pipeline. And here basically the link on my source code that I used, and also the link to the Microsoft repo with the example of a console app that also you can use to create a quality gateway. So that was basically it. And I want to double check with Mikhail, do we have any questions that we need to answer or something like that?
I do not think that at this moment we have questions. Just a second to check.
Okay. And I will put my face again here.
It seems that we have no questions now, but probably we can have later. I suppose that.
Okay, so in any way, I will share with you all the slides with all the links, so you can share that with the attendees. Those slides will also include my email, so if you have any questions, guys, girls, feel free to send me an email. Also, you can try to reach me on Facebook, LinkedIn, Twitter. Yeah, if you will do that, just please send a short message that you saw me at one of the events. So I will make sure that you are the real person, not a robot which tries to be my friend. Okay, and yeah, on that point, thanks for having me. Thanks, Mikhail, for inviting me on this such glorious event, and hope to see you later, and hope to see you later, especially in person.
Thank you very much. Thanks for joining and presenting, and hope to see you soon. Have a nice evening.
You too. Bye.
And for all attendees, thank you for watching Azure Bootcamp. Hope to see you soon at our next event. We really appreciate that you join this event, which is the first in the new format. Have a nice evening.